apply that learning. I hope they've been of a great use to you. If you've not been on one of the workshops before, welcome to you as well. This is workshop number 3 in a series of 4. So this one is all about product development, and that could be physical, or it could be a service, or it could be a web app or internet-based product that you're looking to develop. So we've got an absolutely packed program today. We've got some fantastic speakers covering all aspects of the journey that you might look to go through to get your product out into the marketplace, and most importantly, how to protect that from infringement of somebody else trying to muscle in on what you're trying to do. So I'm going to go through a bit of housekeeping, but before I do that, I'd like to thank very much to our 2 key sponsors. We've got Shakespeare Martineau, who are going to do a talk later on the legals of this subject area. So thank you to them for sponsoring the overall Innovation Challenge, and also to Forrester's IP. So we've got Jag and Greg talking later on, for them sponsoring this workshop in particular. So thank you very much for them. Right, I will press record, otherwise I'll be told off for that. So recording and stop recording. We are recording, so that's good. Right, off we go. So bit of housekeeping before we get going. Please keep your microphone muted throughout the workshop, apart from the speakers, of course. And if you could turn off your cameras as well, if you're not sort of presenting, that'd be quite useful. We've got a bit of a rogues gallery there of some of the speakers. So again, speakers, if you want to turn your cameras off, that's absolutely fine. But if you are talking, then yeah, please leave your camera on. That'd be great. As we go through the workshop, each section, what I want to do is to make sure it's as absolutely interactive as possible. So I'm going to be running the chat in the background, and so if you come up with questions while the presentations are being undertaken, please just drop something in there and I'll introduce it into the presentation as we go along. I think that way it makes it a lot more live, a lot more real, and hopefully a lot more focused on what you, the audience, really need to get out of this. We've got a couple of, we're not going to do Q&A sort of at the end of each 2 or 3 sessions. We're just going to do those within each of the little 20-minute workshops. 2 10-minute breaks, comfort breaks. I will look to shorten those if we're running tight on time. So just be aware of that. So there are 2 breaks built in there. Mr. Nick Fox-Mail, if you'd like to turn your camera off, if that's okay, that'll be absolutely smashing. Thank you for that. So yeah, Q&A as we go along, as opposed to the panel session at the back end. Okay, I'd like to just run through. So the Innovation Challenge is not only about the 4 workshops. They're there to give you a real advantage in the marketplace about having some really great hints and tips and access to real professionals to help you move your company forward. But it's also about the Innovation Challenge, which has got a prize fund at the rear back end. It's really super simple to apply into this. I'll just bring in my screen to show you. So we really do encourage everybody to apply for this if they've got a company that are doing some kind of new product or service or website launch and would like to compete. Super simple. This is the homepage of TBAT Innovation. So that's the home page of website in TBAT Innovation. You can see that the Innovation Challenge, a little blue bit there. So I just click onto that, opens in a new page. It talks about the Innovation Challenge. That was just coming up. So a bit of blurb there about why you should do it, what a great thing it is to do. Obviously, we're currently promoting some of the workshops, but the application process really couldn't be simpler. Just some super, I'll tell you what, Andy, if you could nod when you can see this page, which has got the application on it, because your camera's on and I can see that you're responding to me. So the Innovation Challenge. So a bit about you, so your contact details, email and phone number, a bit about the company. And what we're trying to do there is just understand where you are on your journey of getting out into the marketplace and grow your business. So a few questions around there. A little bit about your business proposition and what it is you're trying to launch into the marketplace. And this is really you telling us that you've got a fairly good grip on who your competitors are, what your costings are going to be, maybe with the cash flow forecast that you've thought about all of that and got that written down. What makes it unique in the marketplace, i.e. what will make it a success and people buy from you in particular. So there's some nice easy questions there. Please put, 50 to, I don't know, 2 or 3 300 words in these if you can. Obviously, some are quite short boxes, projected cost, but some are more. It'd be great if you could tell us in a bit more context what you're up to. And then, of course, there's an opportunity to upload some files. So it might be your business plan or your slide deck. It really is super simple. If you've got some of that information to hand, it should only be like a 10-minute sort of exercise to get your application in. We've extended the opening through till August time, so there's another 2 or 3 months to get your applications in. We've had quite a lot already, which is really, really encouraging, but we really want more people to make it a really exciting award ceremony in October. Right, just move that out the way. So yeah, £5,000 cash prize. And what we've got is that a lot of the people who are doing the talks on the workshops have also put in a prize of like 5 days of their time, 3 days of their time to help the winners. So there's going to be 3 winners, first, second, third, and they can choose which prize package they want from the different suppliers. So it's a real opportunity to get some expert help into your business. Okay, hi there, Trinity and Alexandra, you're new people to us. So we'd ask that you keep yourselves muted, please. Cameras off if you don't mind. And then if you've got questions as we go along, please put them into the chat and I'll be keeping an eye on that and then introducing questions as we go through each of the presenters' presentations. I think. Okay, so why do we want to run this? And I use this kind of saying at each of the workshops. Donald Rumsfeld, I love this quote. And basically, there's stuff you know about this subject area and the stuff you know that you don't know, so you could go and find it out. But what we're trying to do here is open your eyes to the world of the unknown unknowns. So, oh, crikey, I didn't know I needed to know that. The unknown unknowns. So we're not necessarily going to give you all the answers. We can't possibly do that, but it's actually to open your eyes and make you start asking questions, and then you can access the presenters with questions in the chat, and afterwards we'll be sharing their contact details to get that further information you may need. Okay, this is the mug shot of all the fantastic speakers we've got. It is quite a packed program, so we've only got 2 10-minute comfort breaks, and we hope to wrap up by about 4:45. Bit of a marathon session, but some fantastic information going to be coming out. Okay, I'm going to stop sharing now. I'm going to hand over to Andy, who's going to pick up on the sharing, and he's going to run through his presentation. Thank you very much, Andy.
Great, sure. Cheers, Sam. So hopefully you can all see that now. So I shall begin. So my name's Andy. I work for a company called Oxford Product Design. So I'm just going to start with a little bit about the company. So we basically are a full-service product design agency. We were basically founded in 2013, and we've got a staff of about 25 to 30 here. We're based in Harwell. Until very recently, we were right in Oxford City Centre. We've got basically a full, like I said, full service offering here, including state-of-the-art kind of workshop facilities. We have industrial design teams here, mechanical engineering teams, product design teams, and we all work together. And we can take on really any scale of challenge, right away from just a few concept ideas, a few concept sketches, right the way through to developing your product and taking it to production for you. We're independently audited to ISO 9001, and ultimately we're all really passionate designers here, and it's what we do day in, day out, and we love it. So here's really a few of the clients we've worked for. So there's some recognizable names there across lots of different industries, consumer products, medical, scientific products as well. So really, what is product design? So we kind of all got together here and we kind of brainstormed what this meant to us, and ultimately we settled on this. So it's the creative process of developing products that solve specific user needs. And I think that's a really core, really kind of key element there, the user needs. And we'll come back to that later. Broadly speaking, there are kind of three types of design challenge that we find, and these are really ones that clients come to us for. So number one is the innovation. So this is really developing new technology, coming up with new solutions to problems that are out there or problems that you or your companies may have. And it's really about generating something which is novel and unique and something which is really going to generate you IP. We call them nuds, so new, unique, and difficult. Then the other challenge really is about optimization. So very much this can be a client will come to us with a product that they maybe already have on the market, but it's time for the next generation version. And so we take their designs and we will really seek to optimize. That could be in terms of functionality or performance, or it could be cost reduction, it could be an aesthetic refresh, anything like that. And then finally, the third challenge is about diversification. Very often, clients really kind of want to expand their customer base. And so we can help really look and take a deep dive into how existing technology can be reapplied in a new area. And there's a series of kind of structured workshops and brainstorm sessions we run with people where we really kind of delve deep into what are their skill sets, what are the IP they have, and what are the uses that they have. So I'm going to talk a bit now about the design process from kind of quite a high level, kind of a generic process, a typical product design program, as it were. So everybody's probably familiar with the double diamond. We do it ever so slightly differently here. So every design process starts with the problem. And then broadly speaking, there's four kind of phases that design can help in. So there's the discover and define phase, the design phase, the develop, and then the deliver at the end. So really discover and define is really important. It's one of the key bits, and it lays the foundations for getting the design right. So this is where you question, you empathize, and you specify what your product needs to do. Then it comes to design, and that's where we all ideate and create lots of concepts. The develop is then, well, taking that kind of industrial design vision and then developing it into a real world product, proving the concept out, making sure it works. And then the delivery is the transfer to manufacture. And then out at the end comes the solution and your final product. So really, it's laying the groundwork, but that first half is about doing the right things to enable you to do things right further down the process.
And do you include, Andy, so do you involve your potential clients all the way through the all four stages, or is it
absolutely
very much so at the beginning to make sure you're on the right track?
Yeah, for sure. We work, well, it's best to really work collaboratively with the client. One of the things which makes a product
sorry, with the client's potential customers.
Oh, for sure.
So yes, the end user, yeah.
Yes, it's all about kind of verifying and validating your initial kind of research, making sure the product is what the end customer wants, for sure. So how does that kind of look across a typical kind of product development cycle? So really, this is the work in basically entailed in each of those sections. So we'll start by kind of doing research and strategy, and we'll do this in collaboration with our clients, like I say. And then this could be primary use of research. It could be doing workshops, focus groups, that kind of thing. And also challenging our assumptions about what a customer might want from a product. And then we develop that into the formal specification. And then that is then basically what forms the groundwork for the concept generation. And so this is kind of my favorite bit, really, where you're just coming up with as many ideas as you can. You're sketching lots of ideas. It's very fluid at this point. Then typically we would review these concept ideas with the client, pick out our favorites or our favorite bits of each idea, and then that will get developed and honed into a final concept. Once you've got that concept vision, it then goes across to detail engineering. So this is where engineering teams or mechanical engineers may take the design and make sure that everything functions as it should. We'll develop up the CAD, which I'll talk about in a bit more detail shortly, and really start to get prototypes in hand, testing the functionality. And then once we're confident that everything will work, we'll go into what we call alpha prototypes. Now, an alpha prototype is essentially a looks like, works like product, but instead of being built with manufacturing techniques, it will be built using prototyping techniques. So it might be hand-painted, 3D printed prototypes, but it might have the real electronics inside it, that kind of thing. And then this allows you to do sort of more formal testing with customers and users to really make sure that it is what they want, that everybody's happy with it. And it's worth pointing out as well, it's not shown on this diagram, but it's a very iterative process. You're kind of making little tweaks and changes as you go along, as you learn more throughout the process. And once everyone's happy with the alpha prototypes and you're certain then, yeah, we've got a good product design here and it's going to work, that's when we transfer to manufacture. And we'll work with manufacturing companies across Europe or in China, really kind of making sure that the design is transferred successfully. And so what comes out of the tool at the end of the day is what was designed.
Yeah. So I was working with another design company, and I noticed that they were trying to do is a mechanical device that was kind of not clockwork, but looking at escape mechanisms and spring-loaded stuff. So they actually went out and bought lots of other mechanisms that were already out there. So repurposing something that's it, and it might just be a kid's toy that you wind up and it jumps around. But they were looking for little mechanisms, thinking that's really clever. We could. So is that part of both the
100%.
ideation stage and those initial process? You're thinking, great, I've seen something like this, and you have a Google it. Right, let's buy that in, take it apart.
So 100%, it's one of the things that makes a design agency such as ours or a design consultancy so valuable is that we have experience in so many different sectors, but that's 100% what we'll do. It's kind of shown on this slide here, competitor analysis. We'll go and buy competitor products and we'll look at how other people have overcome similar challenges to what you want your product to do. And we'll take inspiration from that and we'll see what can be improved. But you can take inspiration for a design from absolutely anywhere. And so, yeah, our office is filled with bits of products and stuff like exactly like that.
And so how do you then sort of square that off with kind of the IP issue, freedom to operate, and all of that? So yeah, some can be an inspiration, but you got to be careful, haven't you?
Yeah, so it's tricky, and it comes into again this kind of slide here. So the original kind of phase one, as it were, is about defining the requirements. But this is where you do all your research, and so looking into the IP landscape is part of that, and that helps form part of the spec. There may be just ideas that you know will work, but you know that it's a bit of a minefield in terms of IP. And so it's sometimes best to avoid those. But then other times there may be little bits of ways around a certain issue or something like that, or you may take an idea but you're adjusting it or you're improving upon it enough that it doesn't infringe, that kind of thing. It's always a tricky opportunity, and at the start of a process you don't necessarily want to be too restricted by that because you want the ideas to be quite fluid, but it's absolutely something which forms the spec and will form part of your research. And so that's really what this slide is about. So it's about laying the foundations and identifying the opportunities for innovation. And so this could be user-centered workshops, primary user research, that kind of thing. Once you've kind of got your research done and you're confident that actually what you're looking for is kind of what the end user needs, it goes into the concept generation phase. And so this is where we really think wide and explore as many ideas as possible. So you can see some example little concept sketches there, like an example kind of brainstorm where we all sit around, we will scribble and sketch loads of ideas. At this point as well, we're considering things such as ergonomics and human factors. It's really key to get that kind of thing included right from the start. It's no good coming up with a great design that looks brilliant if it doesn't work or it's uncomfortable to hold. And we'll also make kind of rough prototype models, like maybe made from blue foam, just to kind of get something in the hand to feel how something might sort of work or feel. And then once you've kind of generated lots of concepts, you're then looking to hone that down to a final vision. And so this is where the design starts getting a lot more detailed. And typically here we'll move into CAD. So that's using a program such as SolidWorks or Creo to really capture your design in 3 dimensions. And at this point, what we'll do is we'll build the external surfaces, which we call the A surface of the product. And then we can do photoreal visualizations. We can start to explore color, material, finish. There's something which is really key for us because basically everything we design goes to production. It has to work. And so a really big part of this is doing the architecture development of the product. So it's understanding the size of the PCBs, circuit boards inside, understanding the size of the battery required, and being able to fit all of this in the product. And so a big part of every design program we do is laying out the internals so that we can then skin the design around it and make sure it looks great, but there's plenty of space in it for everything that needs to be there functionally. Then it goes on to the engineering team. They will take the A surface CAD and then start to detail it. So this is where all the plastic ribs and all the kind of mechanical fixings, screw bosses, all of that gets added into it. And we start building 3D printed prototypes as quickly as possible to really start making sure everything will fit and everything will work as possible. And then once that's done, as we say, we go into the alpha prototyping, and then we can start to test the design. And that's, again, really kind of, we're quite a long way into the process at this point when you get to the alphas. But you can see here in this picture, it was for a type of gas valve that we designed. We designed a new type of spring to go inside it. So we had lots of prototypes made, and we had to test the repeatability of its action and stuff like that, make sure that it really worked as well as it could. And again, we're considering the hardware and firmware throughout the engineering phase and then fitting it into the alpha prototype. Well, I know there's more on that coming later in the talks.
And so when somebody's asking for something to be IP rated, so it'll stand water and dust ingress and all of that. Is that kind of thing you just build a chamber out of bits of perspex and a hose pipe, and to prove it'll do that, to give you the confidence to then go external?
So you can do that kind of testing, and there is some level of testing that we will do ourselves. But I think also we work very closely with test houses in that regard. And so we can, and from experience, we tend to have a good idea, this is going to pass this test. We know that this will work on this particular fatigue test. We did a product recently which it was a hinge, and it had to go through, I think it was like 100,000 cycles without wearing. And so we developed that, made sure that fits basically, and we worked with a test house to develop that. And then really, once you've done your testing, then you're then moving on to the DFM stage, the design for manufacture. So this is where we get essentially a chance to implement any feedback we may have from the prototype testing, and that's from the client or from the users. So we can make a bit of a change to the design here, or like you were saying about the testing, we may find perhaps this fit of 2 components could be a little bit tighter, or maybe the seal needs to be adjusted just slightly. We can do that now at this stage. So we're really finalizing the design details here.
And is that also with a very much an eye to cost of setting up a production line, what the end cost of the product might be in the marketplace, understanding the end price that the end user might pay, but the supply chain that it needs to go through, and people all want to make their cut.
So cost is a real key critical factor. And so we work with the manufacturing companies, whether they're in China or say the Middle East or in Europe, wherever, because exactly like you say, you may have a particular idea for how a part should be made, but the manufacturer may actually say slightly differently, or the manufacturer may say it might be slightly more cost effective to make it this way. And so then we can take that into account in that DFM stage. So we're liaising with them closely at this point. And it's also as well doing all of the documentation at this point as well. So all of the engineering drawings, specifying all the finishes, the textures, all the critical kind of values, dimensions, that kind of thing. And then the manufacturers will then kind of know exactly the bits that are really critical to get right. And so what are some of the challenges? So I always really like this chart. It basically shows that the cost of changing your mind or making changes to a product design really kind of goes up exponentially the further you go down the process. So this really emphasizes how key it is to get your research and your specification right at the start. Because if you set the project off on a good sort of trajectory to begin with, then you're basically the need for change later is diminished, and that's ultimately going to save you money. And so common challenges across really kind of any kind of design project at the moment, sustainability is a big one. We're getting a lot of that at the moment, and obviously we're really keen on that ourselves here as a company. So we are trying to implement sustainable design practices in as many projects as we can, wherever it's appropriate. There are sometimes things with medical industry products where things have to be disposable, and that's always a tough one to kind of get around. But other challenges really include time and cost. So cost is really key. Developing a product is not cheap, and it can always take longer than people think it can as well, depending on the complexity of the product design itself.
So interestingly, your graph of cost of change as you go through the process gets more and more. But is it also a case that the investment you need to make goes up in a similar graph? Because ideation is not as expensive as design for manufacture, which is not as expensive as laying down the initial tooling, is it? Kind of thing.
For sure. Yeah, so, that's it. And it's funny as well. It's like, the cost increases the further you get down the process, the time it takes increases. We can get to a concept design within a matter of weeks normally, but then it can take months to get the kind of tooling and getting initial parts off of a production line. So the time it takes longer the further you go down. And so really, again, other challenges, IP landscaping, as we touched on earlier, manufacturing, also geopolitics as well, depending where it's being manufactured. Thinking about where is best to get designs made. It may be much more cost effective to go to China or the Far East, but then you have a lot more shipping and transportation costs that also affect the sustainability of the design as well. So we are seeing more and more people looking to manufacture designs locally.
Yeah. Is another challenge sort of managing the expectation of the client that it's not going to be done and dusted in 2 weeks. It's like we've got to do this at a pace where we can make sure we consider everything to get it right as much as we can first time, beyond the ideation and that first diamond when you bring it down, you want to have it. Whereas they just want to go flat out, don't they?
For sure, absolutely. Yeah. I mean, some clients, it depends on budgets as well. Some clients may only have a very small budget, and so that only essentially pays for a small amount of time up front. So it's really about being efficient and identifying the bits where you have the biggest potential for impact, and making sure that you're spending that time wisely.
So just 2 or 3 minutes, John. 2 or 3 minutes.
Okay, cool. So there's a bit here about kind of sector-specific challenges, which we've kind of touched on. So medical device, we do a lot of, but this is a very highly regulated and quite high-risk area. Traceability is really key, whereas consumer, for instance, is much higher volume with much more of a rapid turnover, and the end users tend to be more demanding. In terms of industrial and scientific products as well, these will tend to be lower volume but higher spec, and so meeting the standards required for, say, on the safety helmets, the impact protection requirements and so on is always challenging. So really about engaging with designers, how best to do this. So there's a nice little quote here from Charles Kettering. So a problem well stated is a problem half solved. And I think that's very true. So it's always worth asking yourself these questions when you're thinking about your consumer or your product. So who is it aimed at? Who is the user? Why do they want it? What's the innovation? What's the need being met? And how does this make them feel? In terms of a product, why is it needed? Why is it useful? What do the users want from it? And here's a key one. What is its USP? And then think about environmental things. So when and where is it used as well? And then really get that down into a spec. So the specification is really key to setting your project out on a good trajectory. So get your specification nailed and it makes the designers' lives a lot easier. And then ultimately it ends up saving you money further down the line because you've already considered all of the performance requirements, the usability requirements, the technical specs, all of that kind of thing, and any legislation it needs to meet as well. So really that means to do your homework before engaging with a designer. Be realistic about timescales and costs, and also collaborate with the designers. You will have an expertise in a particular market area that the designers may not. We are not experts in every field, but we have experience in a broad range of fields. So very often our clients will have that extra bit of know-how on a particular issue, and then that's very valuable to us too. And then, like we were just saying, prioritize your critical part elements and make sure you're spending your time effectively.
Yeah. So I imagine you get asked this quite a lot. Oh, that's expensive. What you're going to do? Are you interested in a stake in my company? I bet you get asked that all the time, do you?
We do, you know what, we used to, not so much lately, but we have had that for sure. Yeah, definitely.
So at the end of the day, the product that you design for somebody, they own all the rights for, so they can go off and exploit it.
We are, so something at OPD is we are very transparent about it. The minute the bill is paid, you own everything. It's as simple as that. And so really just find a couple of slides. So the benefits of a user-centric approach is that it enables you to understand your stakeholders, and that allows you to have empathy for your consumer, which means you're going to consider them more in the design. You can verify your assumptions by doing research, but it's about really defining their needs and identifying those opportunities for innovation. And then once you've done that, you will get increased value, they will have more confidence in your brand, and you will have evangelical consumers, as we say. And then also it motivates the designers and it motivates your team to know that you're doing something worthwhile, which the consumers really want.
Yeah.
And that was my talk.
Wow, John. Well, that was a roller coaster of a talk. Thank you so much for that. Fascinating. I with all of the speakers there, I could chat with them for hours on end about their subject area. But I think that's a fantastic introduction about how somebody might work with a design agency and the journey that they should expect to go through. What the common points, failure points are, but where the successes can be made. What you need to consider about making sure it's right for the end user. Fantastic. And later on, we've got Neil coming up from Ignis, who is going to be talking a bit more about the customer piece and also around the electronics and the design of that for future projects. So, and that will dovetail really nicely, I think, with what you were saying about when you've got an overall shape you're happy with, how on earth do I get all these bits and bobs in there? So I think Neil's talk would dovetail really nicely with that. Andy, thank you very much indeed. And sorry to rush you at the end, but tremendously well done. Thank you very much.
Great.
Okay, we have got Lee coming up next from Bulb Studios. Lee, if you're happy to switch your camera on and perhaps open up with your presentation. So Lee is coming at it from a slightly different angle. So Bulb Studios, they're going to be talking about sort of the UX, UI aspect of getting it right for your customers and what the kind of things you need to be considering in that process. So off you go, Lee. And then I'll butt in when I think I've got something to challenge you with.
Lovely. Can you see my screen?
I can, yes.
Fantastic.
Designing for humans. There we go.
Perfect. I couldn't see. I've not got my normal screen set up. So yeah, I'm glad you can see. So hello. So yeah, my name's Lee, as Sam's already introduced, and I work for a company called Bulb Studios. I'm the design director here. I've been specialising in UX and UI and digital product design for over a decade. And yeah, my role here at Bulb is to sort of ensure all of our digital products and experience are delivered on time, budget, and to the highest standards of quality. Just a very quick brief introduction to Bulb Studios. We're an independent digital product studio based in the historical city of Leicester, based right in the city centre. We're a close-knit team of product designers or digital product designers, developers, marketeers, researchers, and we create, as I said, digital products and grow digital brands. We partner with local and national organisations of all different sizes, different sectors, whether it's a kind of startup launching a new product to market, a local business launching a new marketing website, or a global player adding a new app to its portfolio. We've got the experience and the team to deliver on those projects. And we sort of break our services down into digital strategy, digital delivery, which is all of the products we do. So as I said, sort of marketing websites, lead generation websites, native mobile applications, custom web applications, software. We create watch apps, in-car technology, retail touchscreens, basically anything on a screen. We'll have a good go at. So my talk today, I wanted to talk to you about UX, what it is, why it's important, and how it can benefit you in your business venture. And regardless of the stage you're at with your business, your products, your service, the size of your team, your budget, whenever you're thinking and ready to start attracting customers or users, it's important to start striving for a good user experience. So to get started, what is UX? There's a lot of definitions around on the internet. If you Google it, you'll find a million different ways of explaining it. But to paraphrase Don Norman, who's one of the world leading researchers and professors, authors in UX, user experience encompasses all aspects of an end user's interaction with the company, its services, and its products. Designing an experience includes not only sort of making the product, the interface, easy to use and understand for the user, but it's also about designing all of the other experiences and touch points related to the product. For example, marketing campaigns, both social, email, packaging, after-sales support. All of those kind of touch points that a customer or user has with your products are all part of user experience. And at the center of UX is the user. So the end goal of UX design is to provide the user with an intuitive, efficient, and relevant experience. So why is it important? Well, I guess UX is important because it tries to fulfill your end customer user's needs. It aims to provide positive experience that keep your users loyal to your product or brand. With great user experience, your customers will return again and again, engage in more of your products. They'll tell their families, their friends, their colleagues about your brand. And with things like intuitive navigation, clearly organised content, well signposted calls to action, this will ensure that your users throw for your products efficiently and removing any barriers to conversions.
And I think that last piece is you go onto some e-commerce sites and it's just a nightmare. I was on one brand and I just wanted to find out where the stores were and when they were open, and it took me like 30 clicks. And I thought, this. In the end, I just went to one of their competitors where I could just click on theirs and went, we're open from 9 till 4 on a Sunday. Perfect. I'll get along to that. That whole intuitive navigation piece, really, really important, isn't it?
Yeah, it absolutely is, and that is a good example, Sam, of where every kind of touch point is all part of that experience with the brand. If you're even looking for things like opening times or like FAQ information about a product, if things are kind of hard or uneasy to understand, and that just puts barriers in front of potential customers. So user experience is all about simplifying your messaging, all of those user journeys, and just making sure everything is easy to understand, intuitive. It just makes everything a bit more seamless to your users and customers. So this actually kind of a little bit follows on from the previous talk, which is kind of good. There'll be a couple of phrases and techniques that we do that are very, very similar to what Andy's just discussed. So applying UX design, like one of the core practices of user experience is a thing called human-centered design, which isn't it's not a digital practice. It's design agnostic, human-centered design. It's an approach to innovation that UX designers can tap into. It helps us tackle big, complicated, or even unknown problems in product development. Human-centered design integrates the needs of people, the possibilities of technology, and the requirements for business success. It looks at things like the desirability for people, so what a product, service, or features are desirable, how they'll use it, how often they use it, and how a particular product solves a problem, alleviates challenges that people are having. It looks at the feasibility of an idea, so what is technically possible, both within things like budget and time frame, which tend to be some of the big things when you're working on early stage products. You know, what features are needed to bring a product to market. And the last kind of like pillar within that is the viability. What an MVP or version 1.1, how likely are they to become part of a sustainable business model?
So that's quite interesting because I know I've come across this quite a number of times where people just continue to develop their product. They keep developing, and they never put their head above the parapet to sell it or actually get somebody outside to look at it and actually try and use it. So that piece about what's the minimum viable product, I think is really important. Both that still meets all three of those requirements: the people, the business, and the tech. But you don't actually put yourself into a box which you can't get out of to further extend it.
Yeah, definitely. It's also one of the biggest challenges with working with working on early stage ideas and bringing a product to market. Sort of identifying, what is enough to go live, to launch a product, but what's going to bring back value, what's going to help you start generating some income so you can grow this idea further. Sort of identifying early adopters or certain markets or sectors to kind of launch in. All of those kind of aspects are really kind of critical. But one of the things that we found in our sort of experience of working with early stage ideas is you have a lot of entrepreneurs and founders. They have big visions and fantastic visions of what a product's going to look like in 3 to 5 years, and breaking that down into those kind of smaller chunks to get people live out in the market and to start generating is a real kind of, it's a really interesting part of designing products, but they're a real key part of it. So one of the things I just wanted to leave you with, I guess, today is kind of 3 real kind of core UX techniques to help navigate those early stages, from taking those sketch ideas through to concept or an MVP execution. 3 things that we found really, really valuable when working at this stage. So the first one is building empathy with people. Know the people you're designing for. Building profiles, things like addressing your sort of identifiable target market, building personas, building a better understanding of what people's needs and motivations are, how they think, how they behave, and then incorporating that understanding into every aspect of the design process.
I think the classic example there has to be the Sinclair C5. So your market intelligence said people drive 10 miles a day in each direction. The average speed is 20 miles an hour, and they carry 1 person. And so Sinclair developed the C5 electric car to great hurrah in the industry, but actually it completely failed because people did not want it. It just missed the whole of what people want out of a mode of transport completely. I don't know if you're familiar with the Sinclair C5.
I've heard of it, Sam.
It's like a laid back electric car, and you just thought, my God, if you go anywhere near an Arctic lorry, you're a dead man. Shocking piece of technology, but on the surface it met the requirements. That 1-person vehicle, the mileage, the speed, but they never spoke to what the customer might want and what makes what makes you excited about the product.
Yeah, no, exactly. And we've through our past of working with Jaguar Land Rover, we've worked in R&D for a few years and sort of seeing some incredible ideas of where the future of automotive might go. But yeah, when you actually start running focus groups, chatting to existing customers, and start to sort of break things down, understanding how people might start using some of these ideas, you start to get a bit of a better understanding that sometimes people like things simple. They're not after all of the kind of bells and whistles. So it's always interesting pulling it back into that. As designers, we always sort of seek to understand what people need, how they think, and the way that they act. And I think Andy touched on this. Like, if without kind of the insight of users and the people that you're designing for, you start falling into the trap of making assumptions. And as soon as you start making assumptions, that's where you kind of start moving left of centre, and you never. I don't know. One thing that we always say is never assume you know enough. I guess is you should always be talking to users, testing, and kind of bringing them into the process as you go. Now, the second one for us is, bringing a new product to market. As everyone knows, it's very, very challenging. The most valuable products, regardless of sector, industry, they tend to solve problems for people. They make people's lives a little bit easier. You have a good idea, but bringing it to market, it's always a challenge. So what we always try to break down is understanding the problem, but mostly understanding your value proposition. That combines things like problem statements of what you're trying to solve, what the solution might be, but key is where your value is as a business and how that stands out against competitors. We were working with a startup over in the States who had a SaaS product for building like enterprise sales cycles. They had this great idea. They were working in the market currently as consultants. They had a great product, really successful consultancy business, but had an idea to make a SaaS product out of that. They sort of assumed that they could be able to sort of run the whole end-to-end consultancy journey and had ideas for every single step about that, an idea about how the SaaS product would come to market. But by going through some of these processes, we identified just one of what they do in their consultancy business as being a viable product for SaaS to get them off the ground. And we launched that product with them during the kind of COVID years, probably sort of 2021. But again, it was finding out where their value lied, where their price point was, what their product was at that time, and understanding how, that solution can then alleviate some of the problems that it was aimed at, sort of fintech startups, and some of the common problems that they were having was developing products, but then coming to that sales point, getting it out into market. And anyway, this product came along to sort of help alleviate that.
Yeah, and that point, just on that point there, the next workshop is all around, of which Bulwer are going to sponsoring that. Thank you for that, for workshop 4. Is all about getting products and processes and website stuff into the marketplace. And I think that cost of use, certainly for website-based industries, that cost of acquisition of user is really, really important, isn't it? You might go to an investment say it's going to cost me 50p, but actually it could be £2.50. But then what's the ongoing revenue? So, yeah. From what you were saying there with the fintech and the consultancy business.
Yeah, and in that particular business, it was a bit of a sort of slow burner, working in real sort of localized markets, and not some of the main kind of financial areas of the UK, the States and Europe. They kind of moved slightly left of centre, sort of looking at sort of Boston in the States and Birmingham in the UK. As kind of areas before sort of moving into those kind of bigger markets as kind of a starting point. The last of my 3, and arguably one of the most important of the 3, is validating solution to sort of gain valuable insight. So prototyping and testing early, getting feedback from the people that matter, tends to sort of expose fresh perspectives that you fail to identify during the design and development process. Getting that kind of direct feedback from users can be sort of like one of the most powerful justifications about whether a product can be successful or not. If you can use that feedback early in your design and development process, you're not kind of spending thousands of pounds to kind of iterate further on. You're kind of doing it early, whether it's in sort of design-led sort of wireframe prototyping, A/B testing, and those kind of things. Getting that feedback early instead of after launch helps you kind of get that back into the design process.
Yeah.
Again, sort of working in the automotive industry, we were working on a pairing app for an electric vehicle in the past couple of years. This is something where we sort of ran a lot of focus groups. We did a lot of sort of things like contextual inquiry, where we were observing users working through very sort of lo-fi wireframe prototypes, using techniques like A/B testing. One of the interesting kind of outputs of that period of work was, again, sort of honing down on features that are important. What is the priority for a particular application in this particular example? And sort of removing some of the things that are not required. Let's kind of launch with that MVP, that core feature set, and sort of using those techniques to ensure that the idea and then the execution of that idea are hitting exactly where both the business needs it to be and what they're trying to get from that product, but also making something useful that people are actually going to use and, you know, interact with and move forward with. I think I'm actually coming in a couple of minutes early. This is actually a miracle. So just to recap from me, so good UX can help you build trust. And sort of the key three things from us to kind of help you do so is to build empathy with people, understand the problem that you're designing for, and then validate the solution. That's it from me.
Wow, Andy, to be fair, they've been keeping an eye on the chat, but there's some lovely comments about what you've just been talking about. Perfect for me, thank you so much. So some great feedback there from Saul and Lucy. So yeah, it's all not rushing into things, isn't it? It's understanding what people want, trying to get the minimum viable product proven, getting user groups involved during the process. Yeah, absolutely valuable information. Thank you very much indeed for that, Lee. Are you presenting next week as well, or is that Jim?
I'm not. It's going to be another one of my colleagues, Dom, who's going to take over that. Yes, it is. Yeah.
Okay, Lee, thank you very much indeed for that. Everybody, the slides are going to be made available. So if there's some key bits you didn't quite make a note of, they are going to be coming around later on. Right. For once in all the workshops we've run, we're actually ahead of time by 2 minutes, which means instead of a fruit juice, I can get a cup of tea because I've got time to boil the kettle. So we'll see everybody back here, please, in 10 minutes. So 2:05. And then we're going to be talking from Neil Carter from Ignis. Again, thinking about the customer, but also into the electronic design industries. We've got Ahmed talking about regulation and how you need to be thinking about that to go into the medical product industry, and then Conformance talking about more generic CE marking. So yeah, some really exciting stuff ahead. I'll see you in 10 minutes. Thank you very much. Hello there. How you doing, Neil?
Yeah, I'm good, thanks. How are you?
Yeah, I'm doing fine. Just got another minute or so. Yeah, I think. Do you want me to run your slides, or are you running your own? I can't quite
I'll
remember
run my own if that's okay.
Yeah. Do you want to get your your first? Do you want to hand over to you now, and then you can
Well, I
get
need
it up
share now.
in anticipation of a start in a minute or so. I'll be smashing. There we go. Did you get yourself a cup of tea, by the way, in the 10 minutes you had?
No, nobody brought me one.
No, you need a little word with the staff, don't you? Or you...
Okay, so can you see my screen?
Yeah, that's perfect. That's perfect. Okay, I think 2:05. Let's get cracking, Neil, please. So Neil
Yeah.
from Ignis, talking about electronic design, and again also the voice of the customer and the influence that has on what it is you're trying to do. Okay, Neil.
Okay. So hopefully you can all see that screen.
Yes, I
Rather
can.
than just me.
Yeah.
Perfect. Okay, so as Sam said, I'm Neil Carter. I'm the MD of Ignis. Ignis are an electronics design consultancy in Nottingham. We won the Design Team of the Year twice running, and we're about 20 people. So I guess the question is, if I can get the screen to move, what have you done to me, Sam? There we go. So a bit about why I'm here, I guess. So if you have used oil from a certain British Petroleum, I've built safety technology that's used offshore when they actually bring that oil to the surface. If you've been on flights with people like British Airways, Jet2, people like that, and you've bought duty free or food or anything like that, again, you've used the systems that I've built. If you've gone into a football stadium in most countries of the world, you will have used my technology. And then lastly, if you've gone bowling, the system that does all your scorekeeping is one that I've built. But I think the interesting thing is I've done all of that in SMEs in the Midlands. And typically, that's companies with a dozen people or less working with these big brands. So what I want to talk about and emphasize is how we can do this from the point of view of an SME and a startup, small company, how to do things a little bit more hands-on. Not surprisingly, a lot of what I'm going to talk about will be very similar to what Andy and Lee have talked about previously. So market research, get your market research done, get your product valuation. I'm not going to disagree with what's been said before. Simplify your product, work out what your MVP is. But where I'm going to differ a little bit is talk about proof of concept. At the end of the day, give an engineer a problem, he'll solve it. No doubt about it. It's all a question of time and cost. But that doesn't mean it's a good idea to do it. I've seen so many ideas out there from people that, yes, it works, but why? The thing you sell is value. So don't concentrate on the proof of concept, concentrate on the proof of value. That's what allows you to sell. That's what allows you to grow your business. So again, really talking about what Lee was talking about, understand the customer needs. Are they a small private company? Are they a big company? How's that going to work? What's their occupation? What's their interest? What's their purchasing cycle? How are they going to buy this? How are they going to fund it? All of that you need to be listening to understand what you're doing. How do they buy it? Are they going to buy it via distribution channel? Where are they going to buy it? What country? What's that market look like? All of that, as I will hopefully show you, has an impact on on what you do on this product design. And what do they expect from you? How's that support going to work? What do they expect you to be doing for them when you actually make that sale? And I'm a big fan of the model canvas. I'm not sure if many of you guys have come across Steve Blick. I would recommend looking at some of his books. He's the original founder of Agile product development. And this is how you can build this stuff yourself. So one of the problems we have when people come to us is they're looking for something too finished. I remember one case where somebody had come to us that spent lots of money on this finished product, beautifully CNC'd aluminium enclosure, fantastic ergonomics, the whole works. But the mistake they made was they used the wrong technology inside it. And they'd wasted all their money. And what they'd done was built this based on completely the wrong ideas, based on one of their co-founders. And by the time they come to us, it was too late. So not always do you want a PCB. Sometimes you just need a dev board or some dev boards wired together to prove the concept. But equally, you're never going to take that into production. So you need to understand where you are in your journey and what's appropriate for what you're doing. So different ways of developing your strategy. And these, we see most of these in SMEs. You can develop it yourself. That's great. You keep all the IP to yourself. You keep all your money in your pocket. You've got full and total control. But the danger is often it never happens. You know, people don't have all the skills. They might be a software dev, but they're actually not that good at UI, or they may be a hardware dev, but they're not too good at firmware. Or they may think they can do all of them, but eventually fail at all of them. But it is a possibility. You can bring on a technical co-founder. And one of the big problems we see there is co-founders that actually don't have the right expertise. The example I gave earlier, the technical co-founder, his experience was around robotics in warehousing. So they tried to apply that to robotics in sewer pipes, and it didn't work. So you have to be very careful going the co-founder route. You can outsource to freelance engineers. There's so many sites now where you can go and get an engineer for a day, a week, a month, a year, whatever. But the danger there is, unless you've got a team of people, that engineer is always one board spin, one change away from having a completed product. It's always just over the horizon. It's never quite there. So it's a dangerous route, but it is possible. You can outsource to a development firm like us, and the advantage there is we've got a team of people. We're still small enough, but one person gets stuck, you can talk to somebody else. When there's development made, somebody else can check it. So it's an interesting way of doing it.
And I think that's what OPD was saying with Andy, that when they're doing the ideation piece, because they've worked in so many different industries and experienced so many different technologies and got such a library of stuff they've considered for other things in the past, you've instantly got all of that to help you on your product design. And that's exactly what you're saying here, isn't it? It's that broader church of knowledge and experience. That means you don't get into a box and I mean a box as in I've got to go down this route for my development box, not the box.
Yeah, and equally, even if somebody is sort of furrowing a bit of plowing a lone furrow, as it were, there's somebody there that, whilst may not be experienced in that area, by talking to them and trying to visualize and explain the problem, effectively they help you solve it. And you know, again, if a change is made, We have engineers that check that change, do code reviews, do circuit reviews, have different people working on different parts of the project. So that is a very good way of doing it for an SME. And then the last option is partner with a manufacturer. And again, that tends to be more with people that have got an idea that's more obvious. But the danger there, you can make money, but you lose control of your IP. So again, it's different things for different people. So one of the big problems we see is people doing things in the wrong order. And some of them might sound obvious, but you'd be amazed how often people make the mistake. So the first one is get your system block diagram done. Work out what bits are going in it. And that has to tie to the functionality. There's no good building stuff that has got functionality that's not needed. It's going to add cost. Equally, there's no point missing out functionality if you know it's going to be there later, because it's going to add massive expense. And then work out what your components are going to be. Then you can work out your production cost. Then you know you're on a firm footing. You know you've got something that is going to fit the market.
And I think
Doesn't fit the market, there's no point.
Yeah, I think what's important there, Neil, is also to, and I alluded to this earlier, it's if you want to sell into B&Q and B&Q are going to sell it to me, the customer, for £100, you got to knock off the VAT because of their VAT payable, and you, the customer, aren't. So they need to be buying it for sort of £50, but they might buy it through a middleman who needs to be buying it for 25. So you need to be selling it for £12.50. You know, money. I've always said the value needs to double every time it changes hands at the supply chain. So when you're looking at the production cost, don't think, oh my God, it's 50 quid. I don't think people are paying more than 75. That means you've got to sell direct to make money. That is not really a viable product. You need to think, as you say, about the production cost, but how you might sit into a supply chain to make sure that the end price is what the consumer will pay.
Absolutely. But in electronics, it's even worse because a lot of the components come from the Far East. So you have to then worry about the logistics challenges, the cost of transportation, the cost of duty, import, etc., and think how that affects volume. Because that just adds a completely different dimension to what you're trying to work out. So again, create the block diagram, select your production components, make sure those components are going to be available. I mean, we've all heard of supply chain problems. Even before COVID, it was a problem. I remember I worked on a project where a certain phone manufacturer decided to use a component in one of their devices. They'd all gone.
Yeah, I've heard of other companies suffering with that, Neil. That is for sure.
And COVID didn't help with it either.
You know, when they do, I don't know, FPGAs, and they have one model, do you need to also be quite aware of where that might be in its life cycle?
Yeah.
And will the next generation be retro replaceable, or is it a complete respin of the board now?
It depends on the manufacturer.
Yeah.
I mean, it's not even with FPGAs, particularly with things like cellular. If you're looking at cellular modems, you know, with the sort of 3G, 4G, 5G stuff, the sunsetting of GPRS, it's a minefield to try and keep track of. And all of that becomes part of this selection of the production components. And it's massively important. And you won't get it right every time. But if you can hedge your bets to make sure that you're not causing yourself a problem further down the line. So again, estimate the production cost, see how that's going to work, see how that's going to work out in the quantities that you're talking. Make sure you can put those components into your target markets, because not all components are available in all markets, depending on things like encryption, particularly with connected devices. So there's no good building something where your business plan expects you to sell it to China and you can't export that device to China because one of the components has some functionality that means it's not allowed to be shipped there.
So later on in this session, we've got IMED and Conformance talking about CE marking and compliance with legislation. So that again, that comes in onto this point about the choicy components, isn't it?
Absolutely. So then you tend to build your circuit diagram. Again, it's fairly obvious. At this point, this may be based on dev boards. So you picked a core component, you bought a board that has that on, you wire it to a breakout board for a sensor or something like that. And at that point, you can design your PCB. We tend to nowadays order most of our prototypes from the Far East. If you schedule things properly, that will work. But again, you can look at using short-term suppliers in the UK. And that realistically is the way that most people do it now. It's gone are the days where you actually build your own circuit board. And I wouldn't encourage anybody to sort of go down that route. Even with the assembly, it's easier to put it out to a CEM. So find a good local CEM that you trust that's able to build these boards for you.
You know, so there must be a quantity breakpoint. So you're actually saying you order prototypes from the Far East. So that's obviously in tens, ones, fives, tens, whatever. And that's still economical. Whereas, I don't know, in my head, it was always use your local guys up to volumes of X, where X might be, I don't know, hundreds, but then above that, you might go to the Far East. But
that has changed. It's tipped. Volume that you need from the Far East is lower. Yes, the cost is higher than at volume, but the availability of them being able to work on thing is much better.
Yeah.
Again, it depends, but this is stuff you have to work out ahead of time. Don't leave it until you need these things for certification purposes and you don't have the boards. So once you've done that, you go around the loop. We generally allow 2 versions. You should be able to get things sorted in 2 versions if you do the job right. If you're doing more than that, you've got a problem. But the problem may be in a different place to where you think. And I'll talk about that later when I go through some of the sort of lessons learned, things that you should be aware of and traps you need to watch out for. So most or a lot of hardware now needs some form of software, both firmware on the device, but very often to talk to that device, particularly in the IoT world. So again, that gives you a whole new set of challenges. Do you do paid? Do you do open source? Do you choose, choosing your platform, working out what your tool chain is going to be? And again, this is a bit of a moving target. You have to be a little bit careful because the world is changing in these areas. So I had a quick look at the sort of established platforms for IoT. And there's a lot of them.
Oh my God.
And that's a little bit out of date. But the problem is that's not sustainable. So you're going to see them disappearing. You're going to see them merging. So if you're going to build stuff on a platform, it's okay for the proof of concept. It may be okay for the proof of value. But what happens when you want 1,000 or 10,000 or 100,000? That becomes a problem. How are you going to manage them at that scale? How are you going to onboard at that scale? So if you're going to go that route, you've got to be very, very careful. You could just go with the big guys, go for a platform. And, we got Azure, we got AWS, we got GCP. Again, you've got to be very careful the technology you use. I've done some work on some projects where they've used AWS and they've used technology called Lambdas. Great, perfect. It's still not available anywhere else. So now that technology is stuck on AWS. What happens if you want to sell that product into the Middle East, for example? Well, Saudi government won't allow anything that's not hosted in Kingdom of Saudi Arabia. And at that time, AWS had got no hosting there. You know, what if you want to sell it into Qatar? You know, AWS hosting used to be in Bahrain. They were at war. So you've got to be very, very careful on these decisions. You can't just go based on what I see in front of me, what's happening in the UK or your home market.
So we've got about 5 minutes, Neil.
Okay, no worries. I'll talk quick. So nowadays, a lot of people are moving more to a joined together component type solution. And that's very, very good and very, very productive. You can use things like Grafana, Node-RED to build these solutions quite quickly. And we're seeing a lot of people doing that. And that is one simple way for SMEs to build product quickly. And then, you know, develop the enclosure, build the model, print it, transition into injecting molding if that's what's appropriate. Again, brilliant technology. We love it to bits. But again, other people I know are sort of spoken about this area. But certification, again, I know we talk about, is a major challenge. These are some of the main ones people know. But again, that's actually the certification you need to worry about if you're going to sell a cellular product in the world. It's different everywhere you go. Different technologies, different levels of certification. Even ROHS isn't universal. It applies in California, but not in most other states. So, things to remember, and some of these are sort of hard earned, as it were. Beware of data for data's sake. We see so many people building a sensor to capture data. Yeah, that shows the volume of data from prehistory to 25. And machine learning's made a massive, massive impact. You do not have people that can sit looking at data. What's important is insight. Again, I guess a lot of you have seen this quote, data is the new oil, Clive Humby. It's actually a misquote. That's the correct quote. Clive Humby, if you don't know, is the guy that founded the Tesco Club Card. And what that says is, data's great, lots of it is brilliant, but you need to transform it into something useful. Otherwise, you're wasting your time. And the other quote I like is this guy, John Naisbitt, in 1982. We have an economy based on resources, not only renewable, but self-generating. Running out is not a problem. Drowning in it is. And that is a massive, massive thing to remember when you're developing IoT. So again, really quick ones. Don't ignore the law of physics. Again, somebody come up to us, brilliant visualization, concept drawings, the whole works. We worked out the battery life, we worked out the power consumption, not a chance. You cannot get a battery that will fit in that case.
I had quite an interesting one now. I went to see this company. They did products for mums and dads to buy for their babies, and they said, "Oh, we've been approached by a university, their design department. They've got this wonderful idea, and like you get your handheld radio and you spin it up." They said these students have designed one that will heat milk for babies. So I just did a fag packet number, the heat capacity of milk, the time they wanted to heat it in, thermal this, that, and the other. And they needed a flywheel that was 0.5 meter in diameter and weighed 75 kilos, spinning at 10,000 RPM. And I thought, there's no mother in the world who's going to attach that to the back of a pram and then just whip it out in Costas to just heat some milk. You know, laws of physics, you've got to understand them, or at least have an appreciation of them.
Absolutely right. And the number of times that catches people. Don't forget design for manufacture. Can you build it? Can you test it? Can you get the bits? And will it last as long as you want? You cannot make something last longer than the battery will allow. If you need parts of your device to turn off, you have to build that electronics in. Don't expect the software guys to perform miracles. If the electronics won't do it, the software guys can't make it do it. Beware of the snail pace expert. That's the man down the road. He may be great at what he does. He may think he's the expert at all things electronics or computing. He will always be a week away from having it fixed. And that's not how you build a product. And then too many cooks spoil the project. I'm sure you heard the odd adage, put 6 engineers in a room, there'll be 10 opinions. Absolutely true. And then the last one is from our founder. Fletcher's law of prototyping. Higher number of prototypes initially made, the worse the product and those prototypes will be. And that may sound counterintuitive, but it's really not. If your culture is that you're forever building another prototype, you just need that one fix, you just need this done this week, the product will be a problem at the end.
And I think that just hammers home the message from the previous folk about understanding what the customer wants, what is the problem, what's the solution that they want, and actually identifying what it needs to do right at the beginning to try and
Yes.
fast track to what your concept or your alpha prototype needs to be able to achieve. Whereas if you haven't defined it, you're just going to go around that loop time and time again, thinking of extra bits and bobs you could add into it.
And you have to build it in. If the battery needs to last 24 hours, you need to know that. And if that means you need to turn part of the electronics off at different times, you build that in. Don't try and do it later. You know, if you need certain amount of I/O, design that in from the beginning. Don't just try and add a mux later to satisfy, because it will cause all manner of other problems. You know, if you know that you're going to sell it into the US and it's cellular, understand the requirements there. You know, I got burned by their requirements that needed 2 antennas that was diverse for IoT. We didn't know.
Yeah.
It burnt us.
Yeah.
You know, so get these things right up front.
And as again, it's that you can do a lot of the groundwork to be able to go to an organization like yours with a clear idea, or at least a mapped out idea of what it is you want it to do. But as you say, having that breadth of skills and that breadth of experience and access to different technologies is a key component in getting the first products out kind of to time, cost and quality to meet the needs of the end user.
And I guess, I mean, the biggest weapon in our arsenal is the workshop. You know, bringing a customer in, sitting in a room with engineers that have diverse experience and a whiteboard is massively valuable.
Yeah.
And that really has to be the starting point. But it does show that you can do these things without big budgets within the context of an SME or a startup. You just have to be smart about it.
Yeah. And I think those success stories you talked about at the beginning, when it was East Midlands based SMEs having that world presence is staggering. Yeah, fantastic. Neil, thank you very much indeed.
Pleasure.
To me, certainly I found that absolutely fascinating. And that the slide you showed with all the different protocols and platforms and just integrating in the different industries is just staggering, just the complexity of what you need to have an appreciation of to get it right.
Yeah.
So terrific. Neil, thank you very much indeed. Lovely stuff.
Pleasure.
Okay, I'd like to invite Tim and Al, please, if they could pop their cameras on, that'd be good.
Hello, Sam. Thank you very much for having us. Can you hear me?
Oh, that's it. Yes, I can. And hi there, Al.
Excellent.
Hi there.
So I'm going to take a bit of a back step here and let you two have your fireside chat between you. So if I do think of something, be well aware I will be butting in, but I'll try and keep quiet and let you flow through.
I'm not really going to say anything. I'm just here as the nerdometer, so that if he gets a bit technical, I might re-explain it in words for the others.
Lovely. Okay, so so we're talking about, this is IMED consultancy, and it's all about really regulation and the issues that you might face sort of launching a medical based product into that market. Off we go. Thank you very much.
Excellent. Thank you very much. So are my slides showing up now?
Yeah.
Yeah.
Excellent. Thank you very much. So thank you very much, Neil, for that presentation you've just done. Thank you very much, Sam, for introducing us. So Al and I come from IMED Consultancy. We are a regulatory and quality consultancy that's very much focused on medical devices and in vitro diagnostic products. So within this presentation today, we're going to be taking a look at regulatory strategies. How do you get your product, your service, your software to a position where you can actually legally sell it? So we've spoken quite a bit about the design phase at the moment, how you build your product, how you make your product. How do you actually get to the point where you can legally sell your product is what we're taking a look at here. And we're going to be taking a general look at regulatory strategies covering most types of products and software, and then focusing specifically on the medical industry with a couple of application examples, and also looking particularly at medical devices. And really what we're trying to achieve from this presentation today is give you an overview of what a regulatory strategy is, and why it's important to consider your regulatory strategy as part of your design planning. So let's start off. Why are there regulations for products and services? And really the main reason why regulations exist are that governments want to ensure that there is desirable behavior, and undesirable behavior is either discouraged or prohibited within product design. So we take a look at most products and services, and there is generally some level of regulation, either at a general level, things like the General Product Safety Directive, Product Liability Directive, through to the specific industry, technology, and product regulations. So if we take example of like furniture generally has that little annoying tag on it. That's there because regulation requires it to be there to show that the product has an appropriate level of fire safety, so it doesn't immediately burn down your house. And similarly, we see new proposals for things like software where you're using artificial intelligence. There's a new artificial intelligence regulation that's currently being proposed in the European Union to regulate that piece of software and help to protect adverse use of artificial intelligence. So it goes without saying that really following regulation for your product is both important and necessary. If you don't, there's potential reputational damage right through to civil, criminal liabilities. So products, in some cases, if they don't meet regulations, may need to be recalled. They may need to be fixed. And in some serious cases, companies can even be shut down. So it is an important thing to consider. Within the innovation challenge, we take a look at regulation and innovation. Are they compatible together? So regulation can sometimes be seen as a bit of a stifler to innovation. It prescribes certain ways of doing things. It prohibits certain ways of doing things. But it also does present opportunities. And regulatory changes can rebalance whole markets. And people who view changes in regulation as a chance to innovate can potentially grab a market-leading slot, can potentially get IP relevant to the regulation change to make their product really successful in a changing regulatory environment.
I think I'm going to butt in here just because I can't keep quiet because that's me. Interestingly, there used to be an organisation called Nesta who used to make equity investments into new stock companies. And one of their things that they always said was, you need to prove there's a market, a total world market of over $100 million available to what you're trying to do. And I've always disagreed with that. I think that's a useful benchmark, but I've worked with so many companies that have spotted a change in legislation coming in and have now seen a market opportunity that they can exploit. And there was no market there before. So the example would be holes dug in pavements and roads and the reporting of those to the Highways Agency on completion. Always a nightmare. Legislation changed. These guys come up with a fantastic idea. I did some work with them, and we actually got them partnered with an automotive manufacturer who could do Holland Electronics, and that product's out in the marketplace now. There was a legislation change that led to that market opportunity, and that's exactly what you said there. And yeah, I think it's a great place to look for opportunities in new product development.
Oh, very much so. So I'll give you an example here of our dear Henry. So a couple of years ago, there was a ban on really high-powered vacuum cleaners that was enforced, and that required all vacuum cleaners to be made more energy efficient. So it came for a really, really good reason. So consumers were seeing the wattage of the appliance, and that was the dictator of how good it was. So you had manufacturers that were increasingly making products with really power-hungry, inefficient, ineffective motors, and marketing it as being more powerful. So the regulator came and thought this is undesirable behavior. We don't want really energy inefficient products, which also don't work particularly well either. So new regulation was brought in to limit the power that vacuum cleaners were able to output. So there was an absolute need to innovate here to make more energy efficient products. And those who failed to innovate were unfortunately not able to sell their products. So there was a requirement to innovate, a requirement to change products to make them more energy efficient in this case. And we see similar need for innovation within things like electric cars, and even in medical devices where my company usually works as well. So if we get into the nub of this now, so really what we need to do to start looking at what regulations apply to your product is defining what actually is your product. So within medical, we use a term called intended purpose. And really that's what is your product aiming to achieve? And as part of that, we're looking at some of the more specific details. And these have come up as part of the design intent areas that we've covered off in a few other bits of the presentation previously. So how does it operate? Who is using it? What countries do you want to sell your product in? And then if we take a look at some of the medical specific requirements, what medical conditions are you looking to use your product for? And we've got a few examples later to work through how changes in either the technology or the claimed use of the product can actually change which regulations apply to your product. So it does become really important as part of your concept phase to identify what is this product for, how will it be used, and what's the technology in it, both for medical products and also for more general applications. And the key thing to consider here is what's your minimum viable product? The regulators will need to approve the product you're submitting now, not the product you're submitting in the future. So that's a really important point to consider within this definition is what are you actually going to be producing as a product now? Consider your roadmap for later, but for regulatory purposes, the key thing is what are you submitting now as your first product? Because that is what will be assessed by the regulators. And just to point on what different countries. So why am I saying that? So if we consider something like Brexit, for the medical device industry now, that means that there is a different set of regulations in the UK compared to Europe. So in some cases, it's actually more favourable to sell your product in the UK because the regulatory requirements are lesser than in the European Union. In some cases, they're the same. And that applies across every country in the world. Every country in the world has slightly different ways of dealing with how products need to be approved, what the technical requirements are. And we'll get to that a little bit later in the presentation.
Got another question for you, Tim.
Yeah.
So as part of really on that last slide, it's with a medical device, often to get it certified for use, it has to be significantly cheaper and or better, doesn't it, than what's already in play at the moment, as opposed to a Me Too product. There's got to be quite a differentiator, isn't there?
There doesn't need to be a differentiator, but that generally helps with the commercial side of things.
Okay.
So there, in medical devices, there are some Me Too products. It can be difficult to get Me Too products onto the market, but generally speaking, if there's less innovation in medical products, it tends to be easier because as a highly regulated industry, it's looking at safety, and safety comes generally through known and understood technologies. So innovation can sometimes be more difficult to get through within the medical industry, but also where you are able to go through that and break through with an innovation, it's much more difficult for other competitors to also innovate in a similar way to yourselves.
Can I just add there, if you think about NHS for the moment, where that's right, Sam, is actually people are thinking now not just about cost and sustainability and other things. Sometimes it's about patient outcomes, and even if there's no cost saving, even if it costs a bit more, if the patient outcome scenario is materially improved by the product, that might actually still go through. So I think if you're talking about the NHS, that's a slightly different ball game to the rest of the commercial market.
I completely agree with that. So if we take a look at what a regulatory strategy is, there are a couple of key themes within this, and this is something that you need to consider in medical devices and also for more general products as well. So what regulations you need to meet, if appropriate, the level of regulatory risk, and different regulations sometimes have risk classifications, and we'll get into that a little bit later for medical products. And then that will then dictate your regulatory pathway. And a key thing to consider here within your regulatory strategy is slight changes to how you describe your product, how your product functions, how your product's used can change all three of those first points. So getting involved with professionals who have an understanding of the regulatory frameworks can give you a really good understanding of how you can slightly tweak your product and perhaps get it to market quicker, or to be able to demonstrate or get through various different aspects of regulations in slightly different ways through your positioning of the product or tweaks to the technicals of your product as well. So once you've defined those, you then need to take a look at what you need to do to meet those pathway requirements, so the legislative requirements that need to be met. Generally, that'll be evidence, most of it documented, that you need to generate and have either on hand for regulators to be able to see, or indeed in some cases evidence available to submit to regulators to get an approval before you're able to sell your product. So a few considerations for regulatory strategy here. The claims that you make can fundamentally change the regulatory risk, particularly in medical devices, and we'll get onto that a little bit later. But really understanding the regulatory expectations are a critical factor within your regulatory strategy, so you can develop your product for a successful approval, for successful commercialization. And we've just discussed around changing the product features. That can really be a big impact on what your regulatory strategy is. So if you do change during the course of the development what your product is doing or how it's doing it, reconsider what your regulatory strategy is and whether any of those larger changes have an impact upon your existing regulatory strategy. So I've got a few examples to go through. So these are quite medical specific, but are good examples of how changes in how you present a product may change the regulation that needs to be met. So I'll use the example of a chemical chlorhexidine gluconate. So this is antimicrobial. Sorry, someone just mentioned something.
Yeah, that was me. I'm just thinking, I've got a jar of that in my garage, I think.
Yep.
Alongside the mercury and the arsenic I keep in there, that'll be it.
Oh, definitely. This is not a chemical that you want to have around your house. But it's got really good properties around antimicrobial. So infections, bugs, it's really good at destroying those, getting them gone. And you can use it in multiple different ways. So if we consider a mouthwash, you can use it in a mouthwash and it's a cosmetic product. But if you claim that the product is used with an antimicrobial effect, it actually becomes a medicine, it becomes a drug, because you're making that claim of the antimicrobial effect. And similarly, if you've got a wipe, you could use that as a general cleaning wipe around the house. That'll be what we call a biocide. You can use it in a surgical skin wipe, using it as part of pre-surgical prep. That'll be a medical device. And then we could also integrate that chemical into a wound dressing, and then that will be a medical device and a medicinal product. So we've got one chemical there, but how it's used and where it's used can very much define what regulations need to be followed in this case. And I've got another example here of a Fitbit. So particularly within the software of the Fitbit, it's generally used to track what we call wellness, which isn't a medical function, but it does have health data in it, and that can be used for medical purposes. So if we take a look at what the product does, generally, it's really there for fitness, it's for exercise, it doesn't have a medical use. But Fitbit have started using that data for medical purposes. So they have a new feature in there for what's called atrial fibrillation. So that's where you've got a heart murmur that can potentially cause things like heart attacks. So it's something that most people don't know that they have, but can potentially have a big significant medical effect at some point in their lifetime. So being made aware that you have this is something you can then tell your doctor, hey, my Fitbit's told me I've got atrial fibrillation. What does this mean? And they can then put you on the appropriate medication for that condition and then help reduce the risk of you having a heart attack or something like that in the future. So really, it's the use of that existing data in a medical way that then changes the product from being a general consumer product into being a medical device for that specific function.
I think that's really quite interesting there about Fitbit, because the UK is renowned on the whole for having long waiting times to see your doctor. And people think, oh, I've had a heart murmur, I wonder what that was. You ring the doctor, it'll be 2 weeks, so you give up because you feel all right in 2 weeks' time. If the Fitbit is classified to do this and it's saying you've had a arterial fibrillation, you've actually got a warning there that you need to, you've got to follow through on that.
Oh, exactly. Yes.
Actually, no, I don't want to see them in 2 weeks. I've had one of these. I need to see them tomorrow. Thank you very much.
We were talking
really
earlier
important.
about the potential power of big data and machine learning algorithms, and also potential pitfalls of there perhaps being too much data. Medical is very much an industry in which more data tends to be better, so long as it's used for appropriate purposes. Because this is a case where you've got a large amount of data available, and that data can be analyzed in specific ways to see, is there a concern here? Do we need to notify someone of something that they may want to be aware of? So then moving on to regulatory pathways. Once you know what regulations apply, you need to then take a look at what your pathway is to getting your product to the market. So what do you need to do to actually get your product on the market? And I'll use the example here of a scalpel blade. So this is a medically focused one. I've got a non-medically focused one a little bit later. So within medical regulation, there is what we call a risk classification. So depending upon the level of risk, that changes the amount of evidence that you need for your regulatory approval. So I'd use the example here of a scalpel blade. So that can be used for a non-medical purpose. You can use it to cut paper. You can use it for low risk uses in medical. So surgical prep, shaving hair, that's considered quite low risk. So it's a low risk product for its approval. But you can also use it to cut into brain tissue. And that is really, really high risk. Potentially, if it goes wrong, there are quite serious adverse effects. So the regulator in that case, because you're claiming it's used to cut into the brain, it is considered to need more evidence for that use. But ultimately, it could be entirely the same scalpel that's used for all 4 of those purposes. The same physical product, the change in the claim, in this case, changes the level of risk classification. And also, when we consider cutting paper versus the rest, which regulation applies to this product. So a more general consideration here. So I've got a Bluetooth adapter here. This Bluetooth adapter needs to meet what's called the radio equipment regulations. It's a transmitter, it transmits Bluetooth, all the wireless wonderfuls that go through the air now. And this also has a level of risk to it within the regulations. So if you, in this case, follow EU-specific product standards, you're considered low risk, and no external oversight is generally needed for that. But if you have alternative means to demonstrate compliance that don't follow the European standards, you're considered higher risk. So that then requires what's called a notified body, one of the regulators, to review the product and confirm that what you're doing is acceptable and meets those regulatory requirements before you're able to place that Bluetooth adapter on the market. So it's not just medical technology, it is different areas of regulation also have this risk-based approach. So just a little bit on establishing requirements. So some of the key things here are understanding what you need to do to get your product on the market and what you need to develop. So particularly within medical devices, the way that you develop products is really important. So there are certain processes that regulators expect you to follow, and you're expected to put in place what's called a quality management system. So that's a way of controlling the way that you develop your product, similar to the general industry standard of ISO 9001. There's an industry specific standard called ISO 13485 for medical devices that helps you to develop the product in a structured way and meet those regulatory requirements in your product development. So regulators are happy with what you've made. And then on the technical side of developing your product, understanding what your technical performance requirements are, whether there are any safety expectations around how the product is used, how it's operated, any safety controls necessary in the product. And then also, as I was discussing earlier, the level of innovation in your product. Medical is one of these areas where innovation is both good, but from a regulatory perspective, increases some of the timeframes necessary to get your product onto the market because it's less well tested, it's less well established, and therefore the safety profile, perhaps there's a bit more of a question mark over that level of safety, and the regulators will want to see a bit more evidence to show, yes, it is safe, yes, it is an innovation, but it's safe. And a few tips. So first one, early engagement is absolutely critical. Make sure that you understand what regulations apply, how they apply, and what you need to do as part of your regulatory strategy, which should form part of your product development strategy. And then make sure you're identifying up front what you need as part of your regulatory deliverables. So do you need to perform a certain test? Do you need to have a certain standard that you need to meet? Like, for instance, a product standard. If we go back to the example of the Henry Hoover, the product standard is what defines the requirements for that product type. So therefore, you need to meet that standard in order to meet the regulatory requirements. So testing to that standard becomes a required part of getting that product on the market. And I think we should hear a little bit more from Chris later on CE marking of the product, going into a bit more specific detail on CE marking. And particularly for medical products, quality management system is really important. If you do not design and develop your product within a quality management system, you are unlikely to generate the evidence that you need for a regulatory approval of a medical device. So it becomes absolutely critical to make sure that is in place. And just a few other points. So considering design changes. So if you're making design changes as part of your development, consider, does that impact upon your regulatory strategy? And then also, particularly for medical, timeline expectations. If you need to submit to a regulator, what is the approval timeframe for that? And this comes down to both medical and also some non-medical as well. So if we consider the example earlier of the Bluetooth adapter, that will need to go to a notified body. They will have a lead time. They will have an assessment time. That will need to be included in your planning.
Just before you finish off there, Tim, questions come up. So obviously medical regulations are around the products that you produce. The question is, do they also apply to the container that you might therefore put that medical product in? So that might be a tablet, it might be a solution, it might be a cream. That's all part of the regulatory process, isn't it?
Yes. So when we consider a medical device, we talk about the product. So that product needs to be delivered in a certain way. So we generally consider the product to be the product plus its packaging. So the product needs to get to the user in a safe way. It needs to be suitable for use at that point of use, the point of unpacking. So it is included within there, particularly packaging, and particularly where you've got higher risk aspects of packaging, like sterility.
Like the scalpel blade, classic example, I imagine. I can buy it in Hobbycraft and they come wrapped in paper and a piece of card so you don't cut your finger. Whereas all the way through to brain surgery, it must be like triple packed, vacuum, 100 micro, blah blah blah, purity air, and all the rest of it.
Oh, very much so, yes.
Yeah.
So that becomes part of the medical device approval. So how you design your product, how you manufacture the product, how you package it and distribute it are all part of the medical regulation set.
Yeah. Fantastic. Okay.
Thank you. So just a few things in summary. So the first thing, start early. Second one, make sure you've identified what regulations apply to your product. Third one, identify what your regulatory pathway is. How do you legally sell your product? And then once you've got those, you can then identify your characteristics and what regulatory deliverables, documentation, information, submissions you need. So making sure you've defined those at the start of your development cycle, so it doesn't come up towards the end of your development and you find, there are several things I haven't considered within my design, which means I need to go back and redesign my product to be able to legally sell it. Thank you very much.
Tim, absolutely superb. I think, again, it's the depth of knowledge that IMED has within the regulatory framework, specifically medical devices, but the broader church of the regulatory pathway for different devices and products is absolutely fantastic. So a question here from Lucy. May I ask if you know, your company advises about the regulations. Do I need to do the research to find out what regulations my product needs to meet, or is it like a piece of consultancy where you'd say that device, you need to be thinking about A, B, C, and D? You know, when might you get involved with somebody looking to develop a medical device to help them on that regulatory pathway?
So for a medical device, for an in vitro diagnostic product, that's where our consultancy really is focused. So if you've got a product that you think may fall under that, or one that's in the medical sphere that is very much based around physics rather than chemistry, which tends to be drugs rather than medical devices, then that's very much where we would come into the fore. You can get a brief understanding or a good understanding from speaking to people like the design consultancies to which regulations might apply to your products. But then once you've got an understanding of what your intended use is and how it's going to be used, then you can then start taking a look into some of the specifics.
Yeah. Fantastic. I hope that's helpful, Lucy. Tim, out. Thank you very much indeed. Fascinating. And I can see the enthusiasm, Tim, that you've got for this subject area. I mean, you're as bad as me waving your hands about explaining things. And that passion really comes through. So thank you both for making time for this afternoon. As questions come up, I'll get back to you on that stuff. But I think that's it for now. So thank you very much.
Thank you.
And so that was all around okay, regulatory pathways and strategy, and really around the medical device side of things. And now Chris from Conformance is going to talk, I think, a bit more around the broader CE marking world that your products might have to comply with. Now, little anecdote, I first met Chris's boss, Nick, about 15 years ago, and he was a member of the British Caving Association Explosives Committee, I believe, and that's when I first met him. But there we go, that's a whole new part of my life that nobody ever knew about. Chris, over to you, please, to talk about Conformance and CE marking, please.
Okay, thank you. Let's just get the screen share working. It might. I've got some permissions problem here. It might be easy if you shared the slides. If you can do that quickly.
Yeah, I can do that. Yeah. That should come through now. There we go. Does that come through, Chris?
That's good. That's good. Yeah. Okay. Next slide, please. So yeah, I'm Chris Wordley. I'm one of the consultants at Conformance. I'll tell you a little bit about us as a company at the end. So you've probably seen the CE mark on many products over the years. Not everybody understands actually what it is. So essentially this is a European mark, relates to when the UK was in the European Union. And the background to it is that it was intended to be a free circulation mark for products within the many member states of the European Union. We sometimes get people asking us, saying, oh, we'd like to CE mark something, and it's really not a case of that. This is a mandatory mark. If a product is in scope of CE marking legislation, then it must be CE marked, and conversely, if it isn't, it must not be so marked. So it's implemented in legislative terms by the European Commission in Brussels in the form of directives and regulations, and these are issued and they apply throughout the EU 27 and actually beyond. The EU 27 is coloured on the map, but CE marking products in general allows circulation beyond just the EU. Switzerland, the EFTA countries, Iceland, Norway and Liechtenstein, and also Turkey in many respects for products. Turkey has a CE marking regime as well.
Yeah, Chris, are you going to touch on the relationship between BSI, British Standards Institute, and the CE marking world? Is that as we move into the sort of the Brexit, post-Brexit kind of regime, or are you going to kind of focus predominantly on CE marking because there's still a lot of commonality?
There is. So yes, I'm going to start with CE marking. The bulk of the presentation is about that, and then we'll touch on the UK situation at the end, explaining the differences and where things are going. Okay, so the CE mark applies to a vast range of products, from pyrotechnics, which you see there, through construction products, anything that is permanently incorporated in construction works, in other words, buildings. You've got protective equipment, personal protective equipment, things that are worn on the body as a means of protection. Toys is another one. Industrial machinery, machines in general. Lifts, you've got gas appliances there. Okay, next slide. Pressure equipment is another regulated area, so boilers, simple pressure vessels, piping, that type of thing is covered. Equipment that gets used in an explosive atmosphere, for example, in an oil refinery, on an oil rig. Those are also regulated and require the CE mark. Certain equipment that's used outdoors that tends to be noisy and can cause a nuisance, hedge trimmers, lawn mowers, that type of product is also subject to the outdoor noise emissions of outdoor equipment legislation, and requires a marking upon it and has to meet certain limits. Measuring equipment used in the field of legal metrology, from gas meters, electric meters, right through to sort of weighing scales in a sweet shop. Anything where the accuracy of the measurement matters. It's in the field of where you tend to get charged based on the measured quantity. There's also legislation covering environmental aspects, things like the restriction of hazardous substances. You've also got increasing number of eco-design requirements regulating the energy consumption of products and also the materials used in them and various other eco-design parameters. Electrical products are generally in scope as well, as are electronic products and anything that transmits or receives radio communications. Medical devices has already been covered by the previous presenter.
I've got a quick question, Chris, on the chat there. Is CE marking really around product, or does it also cover process?
CE marking, it's both. It sets technical. CE marked products have got to meet certain technical requirements, but there are also administrative requirements that various people involved with the product and it's the supply of that product have got to comply with. An example is the Declaration of Conformity, which people might have heard of and be familiar with.
Okay, All right, thank you.
So whilst there's a very broad scope of legislation covering a vast range of types of product, they all have a similar structure in terms of the detail that's in the legislation, if you care to read it. Usually at the beginning there's a scope saying what the purpose of the legislation is and what kind of products it covers. There's sections detailing the different responsibilities of the different entities involved in the supply of a product. There are essential requirements, which really is the core intent of the legislation. For example, in the case of product safety, the essential requirement is really that the product is safe, and those requirements can spill out into several sentences or quite a lot of pages. It depends on the particular product group and legislation involved. Standards such as British standards, European standards have got a key role to play in CE marking. We'll talk about those later. And there's then the need to assess the conformity of the product against the requirements. Does it comply, in other words? All the legislation requires some kind of information to be provided either on the product in the form of markings or alongside the product, with the product in terms of a user manual or on the packaging, for example. There's the declaration of conformity, which comes at the end of the process, as well as the actual rules on how the CE marking needs to be applied, how big it needs to be, where it can go on the product, and so on. And again, one of the key administrative requirements that's sometimes not realised is that there's a legal need to have what's known as technical documentation, sometimes called a technical file, and that's really documents that describe what the product is and how it complies.
So, like there's 13485, which is essentially, as I understand it, a standard by which you should adhere to give you all the right stepping stones to get a medical product to the point of regulation certification. So it tells you the technical file structure and how you need to do that in the processes. Are there other ones similar to that to help you along that way, or is it each CE marking says this is the documentation you need to comply with? Because one's 3485 seems really quite structured.
Yeah, I mean, 13485 is a standard. It's used in this field of obviously medical equipment. Each piece of legislation has got its own standards associated with it. More commonly, they are sort of about the technical requirements of the product itself, whereas 13485 is more about process.
Yeah.
And procedures.
Okay.
Okay, next slide. So I mentioned the different economic operators. It's important to realise that CE marking is supply side legislation. It's all to do with those involved in the supply of products to the market. I guess of interest here to most people would be the manufacturer. Essentially, if you sell your product under your own brand or with your name on it, then you are the manufacturer, regardless of whether you have actually designed and made the product or not. And other people in the supply chain of the product, which we listed there, also have specific obligations under the legislation. Okay, next slide.
So we've got about five minutes. I don't know if we need to step the pace up a bit here.
Okay, yeah, I think we'll do okay. So in terms of how you go about CE marking a product, the first thing is to establish which legislation actually applies to it. So the scope of each piece of legislation will be a key thing in working out whether it applies to a particular item or not. The features of the product, what the product type is, what it's intended to do. As the previous speaker mentioned, the intended purpose can be a very critical and determining factor in whether a piece of legislation applies to it or not. You also find that if a product is within scope of legislation A, that it might not, it can then get disapplied out of legislations B and C, so that some of them kind of disapply others. Okay, next slide. So we've said that the legislation sets essential requirements. Those are in fairly broad terms in many cases, and it's left to standards. An example is on the right of the screen, to pin down technical detail in terms of exactly what needs to be done. Most of the standards used in the context of CE marking are EN standards, stands for Euronorm. And the key thing to understand there is that the British version, the German version, the Spanish version, if it's the same EN standard, it will have the same technical content, even if it's in a different language. Certain standards have a specific role in the sense that they are associated with different pieces of legislation, such that complying with those standards provides what's known as a presumption of conformity with the essential requirements of the legislation. So if you've got a piece of safety legislation, if you apply a safety standard or standards, in some cases, that are harmonized with that piece of legislation, and your product fully complies, it is seen to comply with the essential requirements in the legislation. Can be quite tricky working out which is the appropriate standard for a given product. That's really comes with experience. Sometimes it's obvious, but in some cases it isn't. Okay, next slide.
Ooh.
So the conformity assessment process, in quite a lot of cases, in principle, this can be done by the manufacturer, and there's no need to involve a third party. Certain higher risk equipment, medical devices being one in many cases, requires a notified body to be involved. You'll often see their number following on from the CE mark.
Got a question come up here, Chris. As we're no longer in the EU, the British companies can still apply for CE marking, and they can self-certify to sell into the European market, can't they?
Yes, they can. In principle, with CE marking, the manufacturer can be anywhere in the world. So that manufacturer's got obligations, even if they're not in the EU or sort of immediately subject to EU legislation.
It's the fact that they're selling into Europe. They have to sell. They can go to a notified body to certify the product, or they can self-certify with the help of companies like yourself.
Yes, indeed. That's a good summary. Yeah.
Okay. Cool.
Okay. Technical documentation is paperwork that you are essentially required to have. It's one of the administrative requirements of the legislation. It's got to describe the equipment, so it's things like bills of material, wiring diagrams, schematics, sales literature in terms of showing the intended purpose and such like. And critically, it's got to show the results of your conformity assessment process, sort of basically showing for each requirement set out in the standards how your equipment measures up, essentially, that it does comply. It might include test results. It might be more inspection based, depending on just what the requirement is. Yeah. The technical documentation also needs to describe what is done in terms of ensuring compliance going forwards. There's this need to keep this documentation for 10 years from the last time the product to which it relates was placed on the market. And generally speaking, nobody looks at this documentation, but in principle, the enforcement authority can request to see it as evidence of compliance. And obviously, if they get wind of a problem, that is exactly what they will do.
And I imagine that if someone's wearing a safety helmet that's been CE marked, okay, that's one that needs to be probably externally tested. But a self-certified product that is CE marked, and something happens like a toy, then if it goes to court, and the technical documentation is not up to scratch, you haven't got a leg to stand on, have you?
No, you will rely on your technical documentation as your defence.
Yeah.
If you've got technical documentation and can produce that, fairly quickly in a plausible way, that is a good thing. If you say what technical documentation, then I think that you will be investigated further and with rather more rigour.
Yeah. A question came up about Northern Ireland. Are they, for CE marking, are they in Europe or out of Europe at the moment, or is it still a movable feast?
I was going to touch on this earlier, but for Northern Ireland is, whilst it's still politically part of the UK, it is, in terms of trading manufactured goods, part of the EU single market, and therefore the CE marking is required there.
Yeah, perfect. Okay.
Okay, next slide. So it doesn't fit this sort of letterbox format very well, but that's an example of the EU Declaration of Conformity, essentially describing what the product is, who's made it, the legislation it complies with, the standards it conforms with, and it's signed and dated by an individual at the bottom on behalf of the manufacturer. Okay. So having got your first product to market, you've then got to think about producing more of them and the controls that you have in place to ensure that ongoing production remains compliant. It's got to cover any changes that you might want to make to your product. You might have part shortages, need to use different ones. You might do a cost reduction exercise. So things which are sort of product based. The other thing is you may also find that new legislation comes along that the first one off the production line didn't have to comply with, but from such a date they will do. So that is something else to keep track on as time passes.
Ooh.
Certainly manufacturers in Great Britain need to be aware of this EU market surveillance regulation. It's intended to protect EU consumers and end users, and essentially it requires that somewhere in the EU there be a responsible economic operator for that product. And basically customs are meant to block products from entering the EU single market unless there is one. And we've got a sister company should anyone need an authorised representative who can fulfil that need. Next slide. So Brexit.
We've got about 2 minutes.
Okay.
Chris. Yeah.
Okay. Separate market entirely now is Great Britain. Independent regulatory regime. However, historically, obviously, all our laws have come out of Europe and have been adopted here. 1st of January 2025, CE marking will no longer be accepted, at least in the case of most products, for products sold in Great Britain, and they will need to be UKCA marked instead. So technically, pretty similar, same principles and process apply. As time passes, divergence may occur in some areas more than others potentially. So that's one to watch. We've already discussed Northern Ireland. Okay.
And so this could be a real problem, because at the pre-Brexit, you could certify your product for use to CE marking standards, sell it across Europe. Now, with the possible divergence of the compliance legislation, you might have a product that suddenly has to meet 2 different sets of legislation that may cause you an issue. You might have to end up making 2 different products of the same, 2 styles of the same product to meet both market needs.
Potentially,
which is bonkers, isn't it? Yeah.
Yes, hopefully you might be able to get one product to comply with both lots of requirements, put both marks on it, draw up a UK and an EU declaration. But yeah, it is more hassle for manufacturers, certainly.
Yeah. Okay.
Okay, next slide. So who are we? We are essentially a company who specialise in CE marking, UKCA marking, and assisting manufacturers get through that process. So it's something we do every day, all day. The benefits of using someone like ourselves really is to tap into our experience, to be confident that actually you've identified all the requirements and identified them correctly. When we do full assessments on products, you can then often apply the same lessons yourselves the next time around, having had the path through the jungle beaten down for you the first time around. We tend to target our guidance specifically at different business needs, whether they're big, small, or in between. So we offer consultancy, we do assessments on products, we've got both standard and custom training. Our web shop has got various materials such as document templates which can be useful, and we also offer update services so that manufacturers can keep up to date with changes in legislation and standards.
Oh, there's Lewis. Okay.
There
Chris,
we go.
So what's really interesting, everybody, is that as regards grant funding and R&D tax credits, what are eligible costs? Certainly, everybody who's spoken so far today, those costs that they may be charging you for their service and for what they do for you are highly likely to be completely eligible as costs in both grant applications, if you're looking for forward stuff, and if you're doing an R&D tax claim looking backwards, more or less of those should be able to be used in that R&D tax claim. So whilst the price tag as a new start young company might seem quite large, if you can actually then further get that reduced through either of those two regimes, it's a really great way of accessing the expertise that you need. Chris, thank you very much for that fascinating talk. Really appreciate that. Folks, we're going to just stop for 5 minutes. We're going to come back at 3:30, please. To be fair, after 2 and a bit hours, we're still only 5 minutes late, so I'm dead chuffed with that. So be back here in 5 minutes for a 3:30 start, please. Okay, thank you. Aha. Afternoon, Jag and Greg. How we doing?
Well, thank you, Sam.
Yeah,
Great
not too
stuff.
bad. Wish I had
Lovely.
a shirt on like you. That looks much
Hey,
more fun
this
than
is
mine.
my pre-weekend music festival shirt. This is. They get better in 2 days' time.
Fantastic. What's
Yeah.
the music festival?
It's one called Glaston Budget, and it's Europe's largest tribute band rock festival. So
That
about
sounds amazing.
8,000 people. Yeah, so it's quite a giggle, and it's literally 2 miles. It's 2 miles from where I live. So
Oh, wow.
Perfect.
yeah, and we still camp. But there we go.
Nice.
Okay, so welcome back, everybody. Thank you for being super prompt on getting going again at 3:30. Got again some fantastic talks coming up, and we're going to look straight away into Jag and Greg from Foresters IP, who are the sponsors of this workshop as well. So we've got absolutely the top draw boys here. I've worked with Jag and Greg on a few projects in the past, and they are excellent. And I've heard them talk before, and this is a fascinating 20 odd minutes we're looking forward to. So take it away, boys.
Brilliant. I'll just
Thank
pull
you
up
very
the slides. There we go. Is that all right for everyone? Can you see it?
It's kind of a bit. It's like it's on a phone. I can
Oh,
see
okay.
it, but it's quite.
Bear with. I'll see if I can sort that. Looking like that. Right. Let's try this.
So we've had talks about product development, CE marking. This next bit's absolutely equally as important. It's about protecting what you've got and making sure that you're in the best place possible to look after the crown jewels that you've now developed. That looks a lot better. Yeah, lovely.
Brilliant. Cool. No problem. Right.
Yes, thank you for the introduction, Sam. Great to be here again. We enjoyed last year, and we're really glad to see that the challenge is back stronger than ever in its second year. So a little bit about us at Foresters. We're a specialist firm of patent and trademark attorneys. So we're a bit different to your sort of solicitors or your normal lawyers that you're probably familiar with. What we specialize in is actually getting patent and trademark protection for our clients, which is different to what a normal, if you like, in quotation marks, a normal solicitor does. Particularly on the patent side, we all have technical backgrounds. I'm a physicist by background. Greg is as well. We'll talk a bit about that a bit later. As a firm, we have 4 offices. Greg and I work from our Birmingham office. We've got offices in Liverpool, London, and Munich as well. So kind of mid to large size for the industry. And we got back a long way, started back in 1884. And because of that kind of history and reputation and size, we're really good at the technical and legal capabilities across all sorts of areas, whether that's life sciences, pharma, through to medical devices, high-tech physics, electric batteries, autonomous vehicles, all sorts of stuff, AI as well. We like to pride ourselves on our clear direction approach to the way we work. So we're very open and friendly, like to be at least with our clients, and try and give advice which is commercially focused, so you guys can really cut through the jargon and make the decisions that you need to make. Because IP can be quite complicated at times, and it's important that you understand what you're getting for your protection, if you like, because it also can be quite expensive as well. So a little bit about us individually. I'm a partner in our Birmingham office, as I mentioned. I work primarily with SME clients across the Midlands. I'm a physicist by background, studied here locally as well. PhD in theoretical physics, undergraduate physics as well. And yeah, we work with good, strong network of advisors like TBAT as well, that we worked with a number of years to support our clients and work in the local sort of innovation space. So we can hopefully, give you the support on the legal side, but also put you in touch with people who can support your business in other ways as well. And I'll let Greg talk a bit more now about himself.
Yeah, sure. Yeah. So hi, I'm Greg. Yeah, I'm a patent attorney, like Jag said as well. So I also have a background in physics. I went to Leicester rather than Birmingham, but yeah, from the Midlands originally, from Redditch, so just south of Birmingham, and pretty much been here my whole life. Yeah, I work with a whole spectrum of clients. So I work with people all the way from man in a shed who's kind of came up with something all the way through to large multinationals. Got experience with a broad range of technologies, so I work on stuff in any one day. It will move between medical devices, fast-moving consumer goods, aerospace and defence, 3D printing, and everything in between. It's quite varied, and it's really good fun trying to keep up with it all. So that's me, pretty much. Yeah. So next slide, Jag. Yeah.
Yes, please. Right. So we'll start with a kind of a high level introduction, really, to what is the term intellectual property. It's bandied around a lot. You often hear about it in the news or in Innovate UK projects and advisors around it. But what does it mean to you as a business? Well, if we take the example of an iPhone, there's all sorts of intellectual property associated with an iPhone, and effectively what it is a kind of a creative piece of work which can be protected. So if we think about the iPhone, there's all sorts of things about the iPhone that make it attractive and valuable to customers and who want to buy it. So if we work through the different aspects of the iPhone and how they can be protected by an equivalent intellectual property right, one of the main ones is the appearance of the iPhone. So the way it looks is very attractive and makes it appealing to customers to buy it. Now, the appearance of a product, the aesthetic quality of a product can be protected through what we call design rights. So that's what designs protect, the way that something looks. And that could be important for you if you're working on products which are particularly appealing to your end user because of the way they look. And it's good to then protect that. If you're investing in that, making it look as good as it is, and then you should protect it because there's value in that for you. Then the other important one, actually, which shouldn't be underestimated, is the power of the brand. So the Apple brand, the Apple logo itself that you could just about see in the left image there, the word Apple, these are all examples of trademarks which can be registered and protected so that other people can't come along.
As well.
Yeah, this iPhone as well, sorry. Yeah. The word iPhone itself is an example of a trademark which can be protected as a registered trademark. And so the advantage of that is that, as you develop a reputation in the field, people really like your product, then other people will come along and sort of try and ride off the tailcoats of your reputation by adopting similar names to kind of almost confuse customers into buying what they think is your product. And so if you protect that brand, you can actually stop other people from doing that. And Apple is a great example where the brand itself, if you put that Apple logo on almost anything, it will sell like hotcakes. Next. And then there's the software behind the iPhone, the iOS, the way that the various apps work on the iPhone. These are all examples of software that can be protected in different ways. One of the main rights is what we call copyright, which is effectively protecting the code that's behind the apps and the interface that can be protected. But there's also potentially room for protecting the software through patents. And I've put a question mark there. We'll talk about it in a bit later, but you don't discount the idea that you could actually protect what the code is doing, the functionality behind the phone, the software. So if the software on the iPhone, there's an app for improving the security of the iPhone or image processing to do around the way in which it takes images. Those are examples of things which could be patented as well, rather than just having copyright protection. And so that can be quite valuable as well. And then you have the functionality broadly about the iPhone, and there's all sorts of things that can be protected when it comes to patents in the iPhone. So there could be aspects of the screen, the chemical composition of the screen, the way that it's been manufactured, the processor within the phone, maybe some aspects of the way that the apps work as well. Anything effectively that has some sort of technical aspect to it and works quite, is appealing to your customers, is something that potentially could be protected by a patent. So that's always worth.
Battery.
Oh, the battery, the battery, the battery as well. Battery management. These are all aspects which could be patented as well. And then you have things called trade secrets, which by the very name, we won't know what the secrets are around the iPhone and what Apple have guarded as a trade secret. And this is something that can be quite appealing if there's an aspect of your product or your business where, if you typically go for patent protection, your patents will get published, so other people will see what's in them and what you're doing. And in some circumstances, if your innovation can't be reverse engineered from your product once you start selling it, then actually maybe it's better to keep it as a trade secret, because then there's no way that anyone can work out why your product is so good, or why your chemical is so good.
We might touch on later on about sort of valuing businesses. That might be on this one or next workshop. But if you've got public facing IP protection like patents, trademarks, design rights, they're fairly obvious what you've got, and they're defensible, and you can tell to people this is it. The trade secret piece is a bit of an intangible, isn't it, as such, because it's not obvious. They've got to get inside your company to understand what those are, and then hence how do you value them quite so well?
Yeah, absolutely. Yeah, it's very much a grey area. I'm not sure how you would, it's very hard to do it without compromising your trade secret. So you've got to be a catch-22. So yeah, it's a good question.
I mean, if you're looking to sell a business though, then and they other people have tried to crack it and they can't figure out what it is, then it's driven by demand, isn't it? There a lot. Like if people care what the secret is, then it's just going to drive that price up. So yeah, it depends how long they've been trying to crack it, maybe as well. 10 years, no dice. Yeah. Okay.
And then you have the other right, which is kind of lesser known, but it's what we call know-how, and that's related effectively to expertise. So you as the innovator, you as an innovating company, there's all sorts of things that you've learned how to do from your experience and the research that you're doing. There's not like a tangible end product or invention that you can kind of point to necessarily, but because you've learned how to do things, literally, that's what it's called, know-how, that can have value. So if you're really good at making certain type of chemical or a certain type of manufacturing technique, that is something that you can commercialize by actually licensing other people to access your know-how to do a similar thing for them, because it takes so much time and effort for them to try and do it themselves that they can actually use your skills instead. And often when you have patents and you sell them or you license them, the know-how associated with those inventions is often licensed as know-how as well. So that can be quite important for consultancy as well. Okay, good. So now we'll start talking a bit about your business strategy. So how does it work? How do these intellectual property rights, what do they mean to you as a business? Well, effectively, all of these things are important because they can protect the business proposition. If you're investing in your business to have a USP and be innovative in the space, then if you can't protect it, then you're open to other people copying what you're doing, unless you've got some way to stop them, and that's what intellectual property rights can do. It can increase the value of your business, again, for similar reasons. If you're looking to get an investor on board or to exit a business, sell on your business or collaborate, then having some of the things that you've got that make you valuable protected, it will increase the value even more because it kind of lessens the risk for that investment or the partner to get on board. Again, it helps to get that investment, grant funding, but it also produces new commercialization opportunities as well. So you as a business, you might be really good at commercializing your invention in the UK because that's where your network is and you understand the sector really well. But perhaps moving it to the US and trying to commercialize there could be quite difficult for you in terms of the capital or not having the links and a suitable partner there. But if you've got your IP protected in the US as well as the UK, then that can be an opportunity to license or get someone else involved to commercialize it for you effectively, who then pays you a royalty. And then you don't really take the risk as such. Someone else is taking that risk, but you're still making money from it, if you like, which you wouldn't be able to do otherwise because you just don't have the means to do it.
The other option is potentially it could be a different field to what you typically operate in. So say you're a medtech SME and you only really care about doing medtech stuff, but you've got a patent that covers something broader than medtech. Then maybe you could license to someone in the automotive sector who's really keen to adopt the technology that's covered by the patent. So that's another potential route for commercialization opportunities. Yeah.
And something else you can do actually with intellectual property rights is reduce the corporation tax that's payable on some of your revenue. Sam's going to talk about that, but that's what we effectively call patent box. And actually that's changed a lot of what some of our clients do who will now file patent applications, not because they're interested in getting really strong, broad patents that they can defend against, infringers, but they actually don't mind having a really super narrow patent if it means that they can claim patent box relief and save on their tax bill. And I'm sure Sam will talk about that a bit later. So, but the reason we put this slide up is to sort of make you think about, well, how is the intellectual property rights that you're looking to protect, invest in, how will they actually help you as a business? What's your strategy and how does it fit into that? Because there's no point, so, sometimes businesses come to us and say, oh, we need worldwide protection and we need to get 100 patents in all these countries. And if we can't do that, what's the point? And these kind of questions come up, and we'll answer that a bit later, but actually that's not always the right question, depending on what you want to do. So we'll talk about that a bit later. And all of you, as you start going along your journey, no doubt IP will come across your desk, whether that's working with venture capitalists, whether it's collaborating with other people or getting grant funding as well. There's always IP considerations involved. You may not know it, like Sam talked about before, the unknown unknowns, but you'll be surprised where it pops up in the business. Yeah. Good.
Okay.
So now we'll
Yeah, no, you go for it, Jack. Go on then.
As I say, but now we'll talk in a bit more detail about each of the main property rights to give you an idea of what can be protected and what's involved. So, Greg, will start with patents.
Yeah, so patents provide protection for technical innovations, or in other words, they protect how things work. So moving around the screen here a little bit, start off in the bottom right, there's a kind of there's a image of a flip-flop there. So that's trying to protect particular innovation about how the thong of the flip-flop's anchored in here to make sure it's a bit more secured. We've got an image here of some nuts and bolts, and that's just to say that inventions don't have to be these massive great leaps forward in terms of what you protect. It can be something as simple as replacing like a nail for a screw or something like that. Jag even had that in one situation where a simple modification like that was enough to get a patent for someone.
Yeah.
Yeah, moving here to the bottom left, this is kind of looking at chemical testing and that sort of thing, and chemicals generally. Those are things that can be protected through patents. Moving up to the top left here, and then also over to this bottom top right, we've got kind of software and fintech here and different things. So these are things that are typically less likely to be patentable, but there are situations where they can be. It's really on a case-by-case basis that you have to look at these to determine whether or not it might be possible to get protection for them. A lot of people tend to think, oh, it's software, I can't get a patent for it. That's not necessarily true. It's always worth checking, we would say. So yeah, door's always open for that. So patents, as I mentioned before, protect technical innovations. They last up to 20 years from when you file them, so it's quite a long time, provided the renewal fees are paid. So in the UK, they're payable every year after the 4th year of filing, I think it is, and then there's different rules in different countries. For an invention to be patentable, it's got to be new, which means that that combination of features which makes up the invention hasn't been disclosed publicly anywhere before the date that you file the application. So it's really important with inventions that you keep them secret and that you don't show other people them. There's been some quite really harsh decisions actually in the last couple of years where people's patents have been found to be invalid because of public disclosures that could have been made. It wasn't even necessarily the case that it was seen, it was just that there was the possibility that it could have been, and it wasn't even necessarily that the invention was disclosed, it was the result of the invention that could be seen, and that was enough to be able to reverse engineer what that invention is. And the second step is for an invention to be patentable is it must have an inventive step. What that means is that the combination of features which makes up the invention mustn't be an obvious thing to have combined together, in essence, to someone of average skill in that field. As I mentioned there, confidentiality is important. So please keep inventions secret if you're thinking about getting patent protection. Software can be complicated, so always get professional opinion. As Jag said, if the software can help the actual overall system potentially run better in some particular way that exists outside of the software, that can potentially be patentable. There are some things like further technical effects like improving security and things like that that can potentially be patentable. Is there anything you want to add there, Jag?
No, absolutely. I think you've covered it all.
Yeah, I got a question there, Greg.
Yeah.
On the confidentiality piece, so as an example, you're developing a product that you want to patent. and you don't have the in-house manufacturing capability, would you you could sign up a single manufacturer under confidentiality to produce the whole thing for you, or would you suggest something like break it down into 2 or 3 sub-assemblies or different suites of components? Yes, they all sign their own and send them out to different manufacturers who also sign their own confidentiality agreement, just so no one's got the whole picture apart from you.
You could potentially do either of those options. The very safest thing to do is to file a patent application before you've done any manufacturing, is what I would say. Is there anything you want to add to that, Jack?
Yeah, I mean, it's a good question, because I think often clients will sort of say, look, well, we don't want to file a patent application yet. Yes, we'll get an NDA in place and that will protect us. But what I think people don't always understand is what the NDA represents. It's effectively a contract to say that if the other person breaches it, then you can sue them for damages, you can take them to court. But at that time, if that were to, there's a couple of things with that. One is, how do you find out whether they've breached it or not? How do you know they've told anyone about your idea or disclosed to someone else? That's the first thing. So how do you police it? The second thing is, if it were breached and you found out about it, do you actually have the funds available to take them to court in the first place? To sue them for that breach. But also, when you get to court, what damage is there that you've incurred at that point? Because if it's a product that you haven't sold, you don't have any revenue as such. The court will sort of say, well, okay, they've breached it. There'll be some sort of injunction against them from doing something similar again. But there's hardly any financial compensation you get back. Is already out there. And so taking measures like Sam suggested about splitting things up, filing a patent application before you start talking to the manufacturers, that's something that actually gets yourself protected, because once the disclosure's happened, it can really make it quite hard for you to put the cat back in the bag and get the protection. And so what Sam described is I think what you described is a good kind of a belt and braces approach if you think you can't afford or you're not ready to file a patent application yet.
Yeah, definitely. Good question. Thank you for that, Sam. And then the last bit to say is that patents are territorial. So you can get a UK patent, a European patent, a US patent, Australian patent, Japanese patent, so on and so forth. So it's important to make sure that you get protection in the territories that are of interest to you. UK is quite a nice place to start because it has very low official fees. So that means that the cost barrier to getting a patent in the UK is comparatively less than, say, if you started in Europe or the US. And then another thing to say is that you don't have to choose at the beginning. It's not like you have to file in all of the countries that you want at the same time. You can use a mechanism by which you can claim priority, we call it, from a first application 12 months after you filed your first one to delay those costs above seeking protection overseas. And there are further mechanisms such as something called an international patent application, which can be used to delay that cost again another 18 months.
So I've got a question on the territorial stuff. If I'm a UK company and I only sell product in the UK and that's all I'm really ever going to be interested in, so I go for a UK patent, does that stop a foreign company selling my product into the UK? If they copy it, and can they sell it into the UK, or if they do so, are they breaching my patent?
So if they're importing into the UK, that is an infringing act of the UK patent, presuming that the product's covered by the patent. So that would capture them, yes, but they would be free to do what they wanted outside of the UK if you only had protection in the UK. One thing to be slightly wary of is if you get manufacturing done overseas and then importing it in, some unscrupulous people may choose to start making knockoffs. So that might be something you might want to protect against.
I have heard of UK automotive switch manufacturers and lamp manufacturers, whatever, going to the big shows in Dusseldorf, and there's half a dozen Chinese companies selling their products under their own badge.
Yeah.
And they're meant to be patented. So that was one industry that I heard of, but there we go.
Yeah,
okay, got about 10 minutes, lads.
Yeah, that's fine. Okay, so I think that's everything on patents, isn't it, Jag, for now? Happy to move on to trademarks?
Right.
Cool.
So trademarks, as you mentioned before, they're all about protecting the branding and the reputation and identity of a business. So the legal kind of definition is the trademark distinguishes one business's goods and services from those of its competitors, so that someone who's buying something with an Apple logo on it can be sure that it's come from Apple. It's protecting the value of it. That's what you're effectively doing as with a trademark registration. And there's all sorts of things that can function as a trademark. It can be a word, it can be a logo, it can be a slogan, it can be a sound as well, it can be holograms, it can be shapes as well, like 3D shapes and objects, although they're a bit harder to protect. And we've got some examples of trademarks there on the slide. You'll see that in some cases you'll have a combination of like a stylized word and a graphic, a bit like Gymshark there. So there's value in protecting there. There's almost there's three marks in there. One is the word Gymshark. There's the icon of the kind of shark face as well. That's a separate mark potentially you can register, and then you can actually register the combination of them. And why would you do that? You know, often clients will sort of say, we've registered our trademark, and then you look to see what they've registered, and they've registered, for example, the whole logo, including the word, and maybe a device like the shark face there together. The issue of that is that actually you haven't actually got as strong a protection as you could have, because in order for someone to infringe the trademark, they almost have to take more elements of the mark to infringe it. So in this example, if the other party had a different word that was slightly different to Gymshark, and they had a slightly different looking shark face as well on their mark, then that potentially might not infringe the mark, because you need to have more things in common with the Gymshark logo if you got it there to infringe it. Whereas if you had protected Gymshark as a word on its own, then they using a similar sounding word or conceptual word to yours would be enough to infringe it. So the broadest protection would be to actually protect the word on its own without any of the graphical kind of indications or devices. And that's often something that businesses should think about, because they can make mistakes early on, and then it can be a bit of a shock later when you try and stop someone from copying it. And they've got as an example, they've got color scheme from Stanley Black & Decker there. They've actually protected that in relation to their goods. So if you develop enough of a reputation in the particular color scheme, you can protect that as well. So all these things you should think about around your brand, how you're using it, particularly in your apps and online. Think about what should be protected. Okay. And what's the cycle like? There's actually a few bits to the trademark cycle. One is when you create the trademark, you need to understand whether or not it can actually be registered as a trademark in the law, because there's some exclusions in the law that certain things which are, say if you have a word which is purely descriptive, like if you had the word fast for trainers, that's unlikely to be registered, because that's describing an aspect of what the trainers are there to do to help someone run fast. Or for example, red for lipstick, very hard to protect. And so some actual brands, if you come up with them, you want to think about, can I actually protect this or not? Is it worth using, or should I go to something else? So that's definitely worth getting advice on at the beginning. Once you've created the mark, people rush into getting it protected and getting a registration, but there's actually a step in between that you should think about, and that is that, has anyone else got a similar mark registered as a trademark already that you might be infringing? The worst situation would be you spend a lot of money devising and coming up with your own brand. You go to protect it, and you might get the registration as well. The UK IPO might just let it through and you get a registration. But then when you look to launch, first thing you get is a cease and desist letter saying, excuse me, but you're infringing our trademark registration. Here it is. Can you please stop? And in that situation, it's really hard to do anything to defend yourself. You literally just have to stop, throw away all that investment and time you spent on the merchandise, on the website, domain name, everything, and start again. Whereas if you clear the mark first by having searches done, which is we do on a daily basis to check for any conflicts on the trademark register, then you can save yourself that potential headache and heartache. And often people sort of do like a Google search or look on Companies House and say, oh, we can't find any other company names that's similar to this. But that's not where you should be looking. You need to be looking on the specialist trademark registers, and there's ways that you need to search for those. So you create the brand, you should clear it, and then think about protection. And once you've protected the brand, you need to maintain it to keep it in force. A trademark can last in perpetuity forever. It's unlike the other IP rights, which are generally limited in time. As long as you pay the renewal fees, you'll keep it in force. But also, you need to use the brand as it's been registered. Otherwise, it can actually become invalid for what we call non-use. And often businesses might register a trademark at the beginning, and then over time it changes, the word slightly changes, or the logo changes over time. And if that happens and you don't protect the new version, it could be that your existing one is now out of date and doesn't actually protect what you're doing. And so you can't actually enforce it against other people who might be copying it without losing the mark altogether.
So can you associate a revised logo with an existing one, saying we've evolved it into this now? So if Gymshark changed their font, if they did the picture, changed the font,
yeah,
from the one they've got to a new one, and change the shark face, could they associate it back to a previous trademark because it is the same company?
Not quite. Yeah, no, not unfortunately not. You unless, I mean, it's worth taking advice on. If it's sufficiently similar already, then they may be not worth registering the mark. But if it is different enough, then you can't. There's no way to link it back. You'd have to get registration again. But in that situation, if you protected Gymshark as a word, regardless of the stylization, then you would have still had value protection for the further stylizations that you come with later. That's one of the reasons that you want to protect the word mark on its own without the logo. So that's a good question, and that actually happens quite often. Yeah, thank you, Sam. Yeah, so this is just repeating what we've said there about how long trademark protection can last, but it is territorial, again, similar to patents. You need to get registrations in the countries that you want to protect. So UK, EU often are the main areas that clients want to have protection, but after Brexit, whereas you could have had a single EU registration that covered the whole of Europe, now you need to get separate UK and EU registrations. And there's a whole piece around that. You don't have to do that immediately. You can wait 6 months to keep the date of your original application, a bit like what Greg described for patents, but it's 12 months, here it's 6 months. But there's still no reason why you can't get registration after that date. So you could still look to get protection in the US, 3 or 4 years down the line and get a successful registration. It just means that anything that was dated in that intervening period that was filed first in the US would be a potential conflict for you, but there's no harm in waiting till later down the line to file it if you don't have any commercial activities there in the short term. Good. So that's trademarks. Greg will talk a bit about designs now.
Yeah, sure. So
just 3 minute, lads. 3 minutes.
Okay, we'll be quick.
Yeah, no problem. So designs protect the appearance of a product. They can cover things like logos, the actual product itself, component parts that are intended to form part of another product, and typefaces and the like. They're useful because they grant pretty quickly, normally the order of a few days, so they can provide you with interim protection, for example, with logos, whilst you're waiting for your trademark to grant. They last a bit longer than patents, about 25 years, but they protect something different, aesthetics, rather than how something functions. The renewal fees are payable every 5 years, and they're relatively low cost, especially if you file lots in one application. Here's some examples of designs, working through from the top right here. This is a top from Gymshark. The more detail that you put into a design, the more limited its scope of protection. So this will be limited to the colorways on it, for example, whereas this vacuum cleaner is in black and white line drawing. So that's got a broader scope. It's not limited to color. This packaging for the product here, this water bottle, is about the contours that are on the outside of the bottle, that sort of thing. You don't